the deep hum of our Earth. Have you ever stopped to think about the sounds our world makes, the ones so quiet we can't even hear them? What if our planet itself had a heartbeat, a soft, constant whisper that goes on and on, deep below our feet? It turns out, it does. Scientists call it the Earth's hum. This isn't like an earthquake, which is a sudden, big shake. The Earth's hum is a constant, super low vibration, like a very deep, quiet rumble that never stops. Imagine a gigantic, silent machine, always running far away, so far that you can't hear it with your ears, but you can feel its tiny, steady tremor in the ground if you pay close enough attention. This hum is everywhere, all the time, even when the world above seems perfectly still. For a long time, no one knew this hum existed. Our ears aren't made to pick up sounds that are so incredibly low in frequency. It's like trying to hear the color blue. But here's the thing. With very special tools, called seismometers, scientists can detect these tiny, constant movements. It was only about 20 years ago that we really started to understand this deep, quiet pulse of our planet. Before that, it was a mystery, just part of the quiet background noise of the Earth. This shows us there are always new things to discover about our world, even about things that have been right under our noses, or rather, under our feet, for millions of years. So, where does this hum come from? It's complicated, and scientists are still figuring out all the pieces, but a big part of it comes from the ocean. Think about the enormous waves crashing against coastlines and traveling across vast seas. These waves constantly push and pull on the seafloor. This powerful, ongoing interaction creates a tiny but steady pressure on the Earth's crust. It's like when you push on a big, squishy ball. It might move just a little, but the push is always there. And that's not all. Changes in air pressure, like big storm systems moving across the globe, also play a part. It's as if the atmosphere is gently pressing down on the Earth, making it breathe out a soft, continuous sigh. To help you picture it, think about your own house late at night when everything is quiet. Maybe you can hear the faint hum of the refrigerator in the kitchen, or the soft whir of the furnace or air conditioner kicking on and off. You might not notice it during the day when there's more noise, but when it's still, that low hum is there. The Earth's hum is a bit like that, but on an unbelievably huge scale. It's the planet's own background noise, a constant vibration that tells us the Earth is not a silent, unmoving rock, but a living, breathing system with its own deep hidden rhythms. This gentle, constant hum reminds us of something truly profound. It tells us that even when things appear calm and motionless, there is immense energy and activity happening beneath the surface. It's a quiet testament to the planet's continuous motion, its hidden life force. It teaches us that there's so much more to understand about our world than what our everyday senses can pick up. It can be a calming thought, knowing that no matter what's happening above ground, our Earth continues its deep, steady pulse, always there, holding us, reminding us of the vast, quiet wonders that surround us. What is dark matter really? Have you ever wondered what fills the space between the stars, or if there's more to our universe than what we can actually see? It's a big question, and the answer might surprise you. Here's the thing. Scientists believe that most of the universe is made of something we can't see, touch, or even detect directly. They call it dark matter. Imagine you're watching a huge galaxy spin, like a giant cosmic pinwheel made of billions of stars. Based on all the stars and gas we can see, it should be spinning at a certain speed. But when scientists measure how fast these galaxies are really spinning, they find something strange. The outer parts of the galaxy are moving much, much faster than they should be. It's like if you had a merry-go-round and you saw kids on it, but it was spinning incredibly fast, way faster than the kids you can see could ever make it spin. You'd probably think there must be a whole bunch of invisible, super strong people pushing it, right? That's kind of what's happening with galaxies. For them to spin so quickly without flying apart, there has to be a lot more gravity pulling everything together. And gravity comes from matter, stuff that has weight and takes up space. But the problem is, we can't see this extra matter. It doesn't glow like a star. It doesn't reflect light like a planet. And it doesn't even absorb light like a dust cloud. It's completely invisible to all our telescopes and scientific instruments. So, scientists started to call it dark matter, not because it's like a shadow or a black hole, but because it doesn't interact with light at all. It's truly dark in the sense that it gives off no light. The idea of dark matter started to really take hold in the 1970s, when an astronomer named Vera Rubin and her colleagues were studying how galaxies rotate. They kept seeing this same pattern. Galaxies were spinning too fast. It was a puzzle. If we only accounted for the visible stars and gas, the galaxies should literally fly apart due to their speed. But they don't. They hold together. This means there must be a huge amount of unseen stuff providing extra gravity to keep them together. So, here's what we understand. Dark matter is not made of the same atoms that make up you, me, the Earth, or even the stars. It's not protons, neutrons, or electrons. It's something completely different. We think there's about 5 times more dark matter in the universe than all the normal matter we can see. Think about that for a second. Most of what's out there, most of what makes the universe behave the way it does, is something we can't detect with any of our current tools. It passes right through us, all the time, without us ever knowing. It's a bit like living in a house where you only see the furniture and the people, but you realize that the house itself, the very walls and roof, are made of something you can't even touch or feel, something that's always there, holding everything together, yet completely hidden. It's a profound mystery, a quiet hum in the background of existence. And that's okay. Sometimes, the most beautiful parts of science are not about having all the answers, but about understanding the depth of the questions. It reminds us that there's still so much to learn, so much left to discover in the vast, silent stretches of our universe. The ocean's loudest unseen sounds. Have you ever stood by the ocean, watching the waves roll in, and thought about how quiet it can be? Or maybe you've imagined the deep, dark places far below the surface, wondering what secrets they hold. We see the calm surface, but below it, the ocean is a world of constant sound, much of it too deep or too strange for human ears to pick up. Here's the thing. Sound travels differently in water than it does through the air we breathe. In water, sound waves can travel much farther and at much lower frequencies. Imagine a sound so deep, so powerful, that it shakes the very water itself, traveling thousands of miles across entire ocean basins. We're talking about sounds that are almost like vibrations, sounds you might feel more than truly hear, if you could even be down there to feel them. One famous example of this is something scientists called the bloop. Back in 1997, special underwater microphones, set up to listen for volcanoes and earthquakes, picked up an incredibly loud, ultra-low frequency sound. This sound was so strong, it was heard on sensors over 3,000 miles apart. Think about that for a second. A single sound, powerful enough to travel across a distance wider than the entire United States. The bloop sound pattern didn't match anything known to science. No ship, no whale, no earthquake. It was too loud, too long, too mysterious. For years, people wondered if it was some giant, unknown creature swimming in the deep, a creature far larger than any whale we know. Others thought it might be ice cracking and shifting in Antarctica. The mystery kept people wondering for a long time. It's like when you're at a concert, and the bass is so low that it doesn't just hit your ears. It vibrates through your whole body, shaking your chest. Or think about a dog whistle. We can blow it, but we don't hear a thing. Our ears just aren't built to pick up those super high-pitched sounds. The ocean has its own version of those unheard sounds, but on the opposite end of the spectrum, incredibly low, booming frequencies that echo through the dark. And these aren't just one-off events. The ocean is full of these deep, rumbling noises. There are booms, trains, and whistles picked up by hydrophones, underwater microphones, all the time, many of them still without clear explanations. Some are from icebergs breaking apart, some from underwater volcanoes erupting, but others remain a mystery, like whispered conversations from an alien world. For a long time, humans barely knew anything about these deep ocean sounds. We mostly focused on what we could see or what impacted our ships. But as we developed better technology, we started listening. And what we found was a noisy, vibrant, and often confusing world. The ocean, which seemed so quiet from above, is actually a giant orchestra playing music we can barely comprehend. The biggest challenge is that we have explored so little of the ocean's depths. Most of it is still a dark, cold, high-pressure unknown. We're only just beginning to truly listen to its ancient heartbeat, and that's why it matters. This ongoing mystery, these vast, unseen sounds, remind us how little we truly understand about our own planet. They whisper of immense forces and possibly unknown life forms hidden in the crushing depths. It's a reminder that even in our modern world, filled with knowledge and discovery, there are still vast, profound secrets waiting to be uncovered, deep beneath the silent surface, echoing in ways we can barely hear, inviting us to listen closer, to wonder, and to sleep with the thought that the world is much bigger and more mysterious than we imagine. The ocean keeps its deepest sounds to itself, a quiet promise of wonders yet to be known. Why do we dream such wild dreams? Have you ever woken up from a dream feeling totally confused? Maybe you were flying, or your pet started talking, or your school was suddenly underwater. Dreams can be incredibly strange, often making no sense at all. But why does our brain, which works so logically during the day, create such wild, impossible stories when we sleep? Here's the thing. Dreams are basically stories our brain makes up while we're sleeping. They happen most often during a part of our sleep called REM, which stands for rapid eye movement. This is when your brain is very active, almost as active as when you're awake. During REM sleep, your body is mostly still, but your mind is off on an adventure. So why are these adventures so weird? Think of your brain as having different departments. When you're awake, the logic department, called the prefrontal cortex, is in charge. It helps you make decisions, understand consequences, and keep things organized. But when you're dreaming, this logic department takes a break. It's like the boss goes on vacation. With the boss away, other parts of the brain become much more active. The parts that handle emotions, memories, and creativity get to run wild. They grab bits and pieces from your day, things you saw, things you felt, things you thought about, and smash them together in ways that don't need to make sense. It's like a painter mixing all their colors without a plan, just seeing what happens. For thousands of years, people have wondered about dreams. Ancient cultures, like the Egyptians and Greeks, believed dreams were messages from gods or glimpses into the future. They thought dreams held special meanings, like secret codes about what was going to happen. Later, thinkers like Sigmund Freud and Carl Jung, famous for studying the mind, suggested that dreams were windows into our subconscious. They believed dreams could show us hidden feelings, worries, or wishes we didn't even know we had. They saw dreams as a way our mind talks to itself, using symbols and strange images. Today, science tells us a lot about what the brain is actually doing when we dream. It's not just random. Your brain is actually working hard, even when you're sleeping. Think of it like this. Imagine your brain is a giant, messy filing cabinet. All day long, new information, new memories, and new feelings get thrown in. When you go to sleep, your brain starts to sort through all that stuff. It decides what to keep, what to throw away, and how to connect different pieces of information. Sometimes, your brain is like a storyteller, taking all these different files and trying to weave them into a narrative. This helps to organize your memories and experiences. It's why sometimes a dream might feel like a weird version of something that happened in your day, or a mixture of different events. For instance, if you spent the day learning about outer space and then worried about a math test, your dream might feature you taking a math test on the moon. Your brain is trying to connect different parts of your daily life, making sense of your world in its own unique way. Dreams also play a role in processing emotions. If you had a stressful day, your dream might be very vivid or anxious. If you were happy, your dream might be light and pleasant. It's like your brain is giving your emotions a space to play out, helping you to handle them without even realizing it. This can be a way for your brain to let off steam or practice dealing with difficult feelings in a safe place. So, even though dreams can feel bizarre and confusing, they're a natural and important part of how your brain works. They help you make sense of your world, process your feelings, and even sometimes remember important things. They are a mysterious, personal theater that plays out every night inside your own head. a unique experience built just for you. They remind us that even in our deepest sleep, our minds are alive with wonder, constantly exploring the borders of reality and imagination. And in that wildness, there is a quiet, powerful purpose. When light acts super strange, have you ever really thought about light? We see it every day. It lets us see the world, read books, watch movies. It seems so simple, just something that lets us see. But here's the thing. Light, simple as it seems, holds some of the deepest, strangest mysteries in all of science. It acts in ways that still puzzle even the smartest scientists. And that's why it matters, because understanding light can challenge everything we think we know about reality. For a long time, people thought light was like tiny little balls shooting out from a source, like little bits of stuff. Then, scientists started to see that light also acts like waves, just like waves in the ocean. It could bend around corners and create patterns that only waves make. So, for a while, there was this big argument. Is light a particle, or is it a wave? Turns out, it's both. And that's where things get really weird. Imagine you're playing catch with a friend. You throw a ball, and it goes through the air. That's like a particle. Now, imagine you drop a pebble into a pond. The ripples spread out. That's like a wave. Light, somehow, is both of these at the same time. It's not one then the other. It's both. Always. This idea is called wave-particle duality, and it's a core part of something called quantum mechanics, which deals with the smallest things in the universe. So, here's an example of how this gets strange. Scientists do this famous experiment called the double-slit experiment. They shine light at a screen that has two tiny slits in it. If light were just particles, you'd expect to see two lines on a screen behind the slits, right? Like if you shot paintballs at a wall with two holes in it. But instead, you see a pattern of many lines, bright and dark, almost like waves interfering with each other. This shows light acting like a wave. But wait, here's what's even stranger. What if you try to figure out which slit each tiny bit of light goes through? What if you put a detector right at the slits? The moment you try to observe which path the light takes, the pattern changes. Instead of many lines, you get just two lines. It's like the light knows it's being watched. It stops acting like a wave spreading out and starts acting like a particle going through one specific slit. This isn't just about light being tricky. It suggests that the act of observing something can actually change how it behaves. Think about it. If you're a student and you're working on a project, you might work one way when you're alone. But if your teacher is standing right over your shoulder, watching your every move, you might work differently, maybe more carefully, maybe faster. Light seems to do something similar, but on a fundamental level. It's not a choice. It's just how the universe works at this tiny scale. This idea of observation changing reality is a huge mystery. It means our universe isn't just a fixed place where things happen whether we look or not. Our looking seems to matter. It's a profound thought. It makes you wonder what else is out there, acting strangely, just beyond our ability to fully observe or understand. So, the next time you see a beam of sunlight, remember that inside that simple beam is a deep, unexplained secret. A secret that tells us the world is far more mysterious and wonderful than we can imagine. And that sometimes, the simplest things hold the biggest questions, inviting us to keep looking, to keep wondering, even when we don't have all the answers. It reminds us that there's always more to learn, and that curiosity is a powerful light of its own, guiding us through the unknown. The mystery of quantum entanglement. Have you ever wondered if things far away could still be connected in a way we can't see or touch? Imagine holding a secret link to something across the universe. Sounds like science fiction, right? But the world of tiny particles, smaller than anything you can imagine, actually works like this. It's one of the deepest mysteries in science, and it's called quantum entanglement. Here's the thing about it. When two tiny particles become entangled, they are linked together in a very special way. It doesn't matter how far apart they are. One particle could be on Earth, and its entangled partner could be light years away, on the other side of the galaxy. But if you measure something about one particle, like its spin, which is like it's spinning clockwise or counterclockwise, the other particle instantly takes on the related opposite spin. There's no delay. It's like they communicate faster than light, which goes against a lot of what we understand about the universe. This idea bothered even Albert Einstein, one of the smartest scientists ever. He called it spooky action at a distance, because he thought it couldn't be real. How could one particle instantly know what the other was doing, without any message traveling between them? It felt like magic, not science. But over the years, many experiments have shown that entanglement is, in fact, very real. It's not magic, but a fundamental part of how the universe works at its most basic level. Think of it this way, and this is just an analogy. Not exactly how it works, but it helps. Imagine you have two special gloves, a left one and a right one. They are made together, a perfect pair. Now imagine putting each glove into a separate, identical box, closing the boxes, and then sending one box to a friend on the other side of the country. You don't know which glove is in your box until you open it. But the moment you open your box and see you have the left glove, you instantly know your friend, thousands of miles away, has the right glove in their box. You didn't send them a text or call them. The knowledge was instant because of how the gloves were linked from the start. Quantum entanglement is kind of like that, but much stranger. With the gloves, you knew from the start that one was left and one was right, even before opening the boxes. With entangled particles, it's like neither glove is definitely left or right until you look at one. And the act of looking at one makes the other one instantly decide its state, no matter how far away it is. It's not about hidden information. It's about a shared reality that only gets decided when one part of the pair is observed. This means that the universe might be much more interconnected than we ever thought possible. Our everyday world, where things are separate and only interact by touching or sending signals, feels solid and clear. But down at the quantum level, everything might be deeply woven together, like an invisible tapestry. It makes you wonder, if tiny particles are so connected, what does that say about everything else? It's a quiet thought, a gentle whisper from the depths of reality, suggesting a universe far more mysterious and unified than we can easily imagine. And perhaps, a reminder that even when things seem distant, a profound connection might still exist. Are we alone? The wow signal. Have you ever looked up at the vast dark canvas of the night sky and felt a deep, quiet wonder? You might ask yourself, is anyone else out there, beyond our small blue planet? For many years, scientists have used powerful telescopes, not just to look at stars, but to listen. They listen for tiny whispers, for any sign, any message that might be traveling across the incredible distances of space. And sometimes, just sometimes, they hear something truly strange. One night in August of 1977, at a place called the Big Ear Radio Telescope in Ohio, something remarkable happened. A volunteer named Jerry Eman was looking over printouts from the telescope. These printouts showed how strong radio signals were. Most of the time, the signals were just background noise, like static on a radio. But on this one printout, there was a sudden, clear spike. It was a signal that stood out, loud and strong, for about 72 seconds. It was so strong, so clear, so different from anything else they had ever seen, that Jerry Eman circled it on the paper and wrote a single word next to it. Wow. And that's what we still call it today, the wow signal. Think about it like this. Imagine you are sitting alone in a huge, quiet library. You're reading, and all you hear is the rustle of pages or the distant hum of the building. But then, for just a little over a minute, a clear, beautiful note from a piano rings out, loud enough to hear, coming from somewhere far away in the library. Then, just as suddenly as it began, it stops. You wait. You listen. But the note never plays again. That's a bit like the wow signal. It was a singular event. It came from a specific direction in space, near a group of stars called Sagittarius. But despite many attempts to listen again, that same signal was never heard. Here's the thing that makes it so mysterious. Radio signals from space usually have certain patterns. They might be from natural things, like exploding stars, or from human-made satellites. But the wow signal was really specific. It was at a frequency, a particular radio channel, that is often thought of as a quiet channel in space, where signals from our own planet don't usually interfere. It was also very narrow, meaning it was like a focused beam, not a wide, messy broadcast. This narrowness, combined with its strong, clear presence and the fact it only happened once, made people wonder, could it have been an intelligent message? Could it have been sent by someone or something very far away? The truth is, we don't know. Over the decades, many theories have popped up. Maybe it was a passing comet or a super-secret Earth satellite. But none of these explanations have perfectly fit all the details of the signal. It remains one of the most famous and most puzzling events in the search for life beyond Earth. And that's why it matters. The wow signal is like a faint, beautiful echo of a question that floats through the universe. Are you there? It reminds us of the endless possibilities held within the vastness above. Even if we never find a clear answer to what that wow really meant, the mystery itself is a powerful teacher. It gently encourages us to keep looking, to keep listening, and to remain open to the incredible, unexplained wonders that drift through the silent depths of space, reminding us that even the briefest whisper can hold the deepest secrets of the cosmos. The vanishing act of rogue waves. Have you ever looked at the ocean and thought you understood its power? You see the waves, some big, some small, all moving in a rhythm. But imagine this. You're far out at sea, and the waves around you are maybe 10 or 15 feet high. You feel the ship sway, you're used to it. Then, out of nowhere, a wall of water rises up. Not 10 or 15 feet, but 50, 60, even 100 feet tall. It appears from nothing, crashes down with unbelievable force, and then, just as quickly, it disappears back into the normal waves, leaving hardly a trace. What was that? These are called rogue waves, or sometimes monster waves or freak waves. They are not like tsunamis. Tsunamis are caused by huge disturbances, like earthquakes under the ocean, and they spread out over vast distances. Rogue waves are different. They appear suddenly in open water, often when the sea isn't even that stormy. The main thing that makes them rogue is their extreme height compared to the other waves around them. They are like a single, towering skyscraper appearing in a neighborhood of regular houses, then just vanishing again. For hundreds of years, sailors told stories about these terrifying giants of the sea. They spoke of incredible waves that could swallow ships whole, appearing from clear skies. For a long time, scientists and engineers thought these stories were just myths, exaggerations told by frightened sailors. They figured the waves were probably big, but not that big. After all, the mathematical models they used to predict ocean waves didn't allow for such extremes. They believed the biggest wave you could get was a certain height based on the waves around it. But here's the thing. In the last few decades, with better technology, we've started to see evidence that those old sailors were telling the truth. Instruments on oil rigs and ships have measured these incredible waves. One famous example is the Druppner wave, which hit an oil platform in the North Sea on New Year's Day, 1995. The platform measured a single wave over 85 feet tall, appearing out of a sea where the other waves were much smaller. This measurement proved that rogue waves are very real. Imagine you're playing a video game, and all the characters are about the same size. Then, all of a sudden, one character on your screen is 3 times bigger than anyone else, just for a second, then shrinks back to normal. Rogue waves are a bit like that, an unexpected, enormous outlier that defies the usual rules. Scientists are still working to figure out exactly how and why these waves form. Some ideas involve smaller waves combining their energy perfectly in just the right spot, like many small pushes coming together at the exact same moment to create one giant push. Other theories suggest that strong currents or wind patterns might play a part, but we don't have all the answers yet. The idea of rogue waves shows us something important about the world we live in. Sometimes, the things we think we understand completely, like the physics of ocean waves, still hold deep secrets. It reminds us that nature has a powerful, unpredictable side, a wildness that can surprise even our best scientific minds. It makes you quietly wonder about all the other things out there, unseen and unexplained, waiting for us to discover them. The ocean, deep and vast, continues to whisper its mysteries, reminding us that there is always more to learn, always more to feel humble about. Why birds fly far, far away. Have you ever looked up on a crisp autumn day and seen a huge group of birds, maybe hundreds, flying high across the sky? They seem to move with a single mind, a dark shifting cloud heading somewhere far away. It's a sight that makes you wonder, where are they going? And what makes them go? These birds are on one of the most incredible, unexplainable trips in nature. This long journey is called migration. It's not just a fun trip. It's a trip for survival. When winter starts to arrive and the air gets cold, things change quickly. Food becomes hard to find. The ground freezes solid, so insects hide. Berries disappear from the bushes. So many birds fly to warmer places. They go where there's plenty of food to eat, and the weather is gentle. And then, when spring comes and their old homes warm up, they often fly all the way back. But here's the thing that puzzles us. How do they know exactly where to go? How do they know when to leave? It's not like they have tiny maps or little calendars. For thousands of years, people have watched this happen and wondered. Back in ancient times, people didn't understand it at all. Some thought birds simply disappeared into the earth, maybe slept underground all winter long. They couldn't imagine a small bird could fly so incredibly far. Scientists today know a lot more about bird migration. They know birds use the Earth's magnetic field like a compass. They use the position of the sun during the day and the stars at night to guide them. They can even smell certain places to find their way. But even with all this knowledge, the deeper why and how still hold many secrets. It's not a choice a bird makes, like picking what to wear that day. It's something much, much deeper. It's an instinct, a powerful, ancient pull that guides them. Imagine this. Think about how your body just knows to breathe, or how your heart beats without you ever telling it to. These are automatic, vital things your body does. Bird migration is like that, but on a grand global scale. It's a built-in program. It's like a quiet whisper in their very bones, telling them it's time to go. What's truly amazing is how a young bird, flying for the very first time, can know exactly where to go. It might fly thousands of miles to a place it has never seen before, guided by this invisible force. Think about it this way. Maybe your family has moved before. It's a big change, a long journey to a new place. You move for a better school, or because a parent gets a new job. For birds, it's about survival, about finding what they need to live. It's a journey driven by the most basic needs. It's a constant quest for life itself. There's a quiet wonder in watching these tiny creatures take on such enormous journeys. They follow a deep, unseen current in the world, a call to a warmer land, to food, to survival. It reminds us that there are forces at work in nature, and maybe even within ourselves, that we can't fully explain. Sometimes, the most amazing things are not the ones we can completely break down and understand with charts and lists. They are the things that hint at a deeper wisdom, a built-in purpose in the world around us. The birds, with their yearly trips across continents, whisper to us about this great mystery. They show us that life is always moving, always seeking, always finding a way. They are guided by something ancient and profound, something we can only look at with quiet awe. And in that wonder, perhaps we find a calm understanding of how little we truly know, and how beautiful that mystery can be. The strange case of ball lightning. Imagine a thunderstorm outside, dark and rumbling. Suddenly, a glowing, floating orb of light drifts through your window, silent and mysterious, before vanishing just as quickly. Could that really happen? This is not a scene from a fantasy movie. It's what people describe when they talk about ball lightning. Here's the thing. It's one of nature's most puzzling mysteries. We're not talking about regular lightning, the kind that flashes from clouds to the ground. Ball lightning is different. It's reported as a sphere of light, sometimes as small as a golf ball, sometimes as big as a beach ball, that can last for several seconds, even a minute. It moves slowly, sometimes floats, sometimes zips around, and can even pass through walls or appear inside buildings. And then, poof, it's gone. Sometimes with a quiet hiss, sometimes with a loud bang, or sometimes just fading away. For hundreds of years, People have seen these strange glowing balls. Sailors in olden times would write about them in their ship logs. Farmers, scientists, and even astronauts have reported seeing them. Imagine a storm raging outside, and a glowing ball the size of a soccer ball slowly drifts into a room, floats for a few seconds, and then disappears without a trace. These aren't just old tales. Modern witnesses, including airline pilots and weather scientists, have also described similar events. But here's the problem. It's incredibly rare, and it's almost impossible to study in a lab. We can't just make it appear when we want to. This means scientists have to rely on eyewitness accounts, which can sometimes be tricky because people see things differently, especially when they're scared or surprised. So, scientists have many ideas about what it could be, but no one really knows for sure. Think about a puzzle, like one of those really old ones that no one has ever quite figured out. You have all the pieces, but they don't quite fit together to make a clear picture. Ball lightning is a bit like that. We know it happens because so many different people have seen it in different places at different times. But we don't know how it happens or what it really is made of. Is it some kind of super hot plasma, like the stuff stars are made of, but trapped in a small, cool-looking ball here on Earth? Or is it a special kind of chemical reaction happening in the air, sparked by a regular lightning strike? Some researchers even wonder if it could be related to electricity flowing through things like power lines or phone cables, somehow forming a temporary, glowing bubble. This might sound a little wild, but some theories suggest it could involve superheated air or even tiny bits of dust or smoke that get electrically charged. Imagine static electricity, the kind that makes your hair stand up when you take off a hat in winter, or gives you a tiny shock when you touch a doorknob after walking across a carpet. Now, imagine that same kind of electric charge, but much, much stronger, and somehow collected into a glowing, floating sphere that moves on its own. This can help you understand how something we know, electricity and charged particles, might be involved in something we don't fully understand, ball lightning. It's a much bigger, much more mysterious version of that simple static electricity. This strange light pushes us to think outside the box, to consider possibilities we hadn't imagined. The fact that it's so mysterious, that we can't fully explain it, makes it even more fascinating. It reminds us that even with all our knowledge and technology, nature still holds deep secrets. We've sent probes to other planets and explored the deepest parts of the ocean, but there's still a natural phenomenon happening right here on Earth that baffles us. It's like a hidden door in a familiar house. You know it's there, but you haven't found the key yet. So, when you hear the distant rumble of thunder or see a flash of lightning split the sky, take a moment to wonder. Beyond the storm, there might be a silent, glowing sphere, moving with its own strange purpose, a tiny, glowing question mark in our world. It's a reminder that not everything in the universe fits neatly into a textbook. There are still wonders that defy our understanding, waiting for someone, maybe even you, to unlock their secrets. And that's why it matters, because these unsolved mysteries invite us to keep observing, to keep questioning, and to keep learning, even about the very air around us. They show us that the most profound discoveries often begin with a moment of quiet curiosity about something truly strange. What makes the sun's corona so hot? Imagine standing far from a bonfire. You feel the heat, right? But what if, as you moved away from the fire, the air around you suddenly became much, much hotter than the flames themselves? Sounds impossible, doesn't it? Heat usually spreads out and gets cooler as you move away from its source. Well, that's exactly what happens with our sun. A star so vast it holds us in its gentle, powerful grip. We all know the sun is hot. Its surface, where light and warmth truly begin, is scorching, about 9,940 degrees Fahrenheit. That's hot enough to melt almost anything. But then there's the sun's atmosphere, its outer halo, called the corona. This corona is the faint, shimmering crown of gas that we can only truly see during a total solar eclipse. For a long time, it was just a beautiful, fleeting sight. Here's the strange part, the big puzzle. This corona, this outer layer, is unbelievably, mind-bogglingly hot. We're talking millions of degrees Fahrenheit. Not just a little hotter than the surface, but hundreds of times hotter. How can the outer layer, be so much more intense than the fiery surface it surrounds? How can the air around the fire be hotter than the fire itself? This mystery has puzzled scientists for decades, a deep cosmic riddle whispered across the vastness of space. Think of it like this. You're baking a cake. The oven itself is set to 350 degrees. Now, imagine if, when you open the oven door, the air right outside the oven in your kitchen was suddenly 350,000 degrees. It just doesn't make sense, does it? You expect the heat to spread out and become less intense. But the sun's corona defies this simple logic. Scientists have some ideas, some truly fascinating thoughts about what might be happening. One main idea involves something called magnetic reconnection. The sun is a giant ball of electrically charged gas, and it has powerful magnetic fields that twist and tangle like invisible rubber bands stretching and knotting up. Sometimes, these magnetic lines snap and reconnect suddenly, releasing huge bursts of energy. Imagine stretching a rubber band until it snaps. That sudden release of tension creates a little heat. On the sun, these snaps are on an enormous scale, perhaps flinging energy outwards into the corona, heating it up to those extreme temperatures. Another idea talks about alpha waves. These are like ripples or vibrations that travel along the sun's magnetic field lines, carrying energy from the surface up into the corona. Picture a long rope tied to a tree. If you shake the end of the rope, waves travel up it. The sun shakes its own magnetic ropes, sending these waves high into its atmosphere. And maybe these waves break in the corona, much like ocean waves break on a beach. When they break, they dump all their energy into the gas there, making it incredibly hot. It's like the energy of a breaking wave, but instead of water, it's invisible magnetic energy, and instead of sand, it's super hot gas. These are just ideas, not proven facts. We have sent probes closer to the sun, gathering more data, trying to listen to the sun's whispers and understand its secrets. Each piece of information helps us get a little closer, but the full answer still hides in the blazing depths of space. So, even with our smartest minds and most advanced technology, this blazing crown of our sun remains a beautiful mystery. It reminds us that even the most familiar things, like the sun that warms our day, can hold secrets beyond our current grasp. It teaches us humility, and that the universe is always ready to surprise us, to show us something new, asking us to keep watching, keep wondering, and keep dreaming of answers. And perhaps that's one of the most profound things about science, not just finding answers, but discovering new, incredible questions that keep us looking up. The power of your mind. Placebo effect. Have you ever wondered if what you believe could actually change what happens to your body? It sounds like something out of a fantasy story, doesn't it? But there's a powerful and mysterious phenomenon in science that suggests your mind holds an incredible, quiet power over your physical self. This is called the placebo effect. Here's the thing. The placebo effect happens when someone feels better or their symptoms improve, not because they've received real medicine, but because they believe they have. Imagine taking a sugar pill, thinking it's a powerful painkiller. And then, your headache actually starts to fade away. The sugar pill didn't have any medicine in it, but your mind, expecting to feel better, somehow triggered your body to actually feel better. It's not just a trick of the imagination. Scientists believe it's about the brain sending signals. When you believe something good is going to happen to your body, your brain can release its own natural chemicals. These might be endorphins, which are like your body's natural painkillers, or other feel-good chemicals that can reduce pain, calm anxiety, or even help with symptoms. So, it's not the fake medicine doing the work. It's your brain responding to your belief. Doctors and researchers have known about this for a long time. Even centuries ago, medical thinkers noticed that sometimes simply the act of caring for a patient or giving them something that looked like medicine would make them feel better even if the medicine wasn't real. During wars, when real drugs were scarce, doctors might give soldiers something harmless just to ease their minds and hopes. And often, those soldiers reported feeling better. This wasn't about tricking people for fun. It was about noticing the profound connection between the mind and body. It showed that expectation isn't just a thought, It's a powerful force. Think about it this way. Have you ever been told you're really good at something, like a sport or an art project, and then, just because someone believed in you, you felt more confident and actually performed better than you thought you could? It's a similar idea. Your belief in yourself, sparked by someone else's belief, changed your ability. With the placebo effect, it's your own mind sparking that change within your body. Or maybe you've had a cold, and someone gives you a special tea that they swear makes you feel better. Even if it's just regular tea, if you truly believe it will help, you might start feeling a little better faster, just because your body is preparing for that positive change. The placebo effect teaches us something truly profound about our own inner world. It shows us that our thoughts, our expectations, and our beliefs are not just abstract ideas floating around in our heads. They have real, measurable effects on our physical reality. It's a quiet whisper from the universe, reminding us of the amazing, still mysterious ways our brains work. It means that the way we think about ourselves, our health, and the world around us might just be more powerful than we ever imagined. It's not a magic cure for everything, but it's a gentle, humbling reminder of the incredible potential that lies within each of us. Is time really just a river? Have you ever looked at a clock and truly wondered what time is? We often say time passes, or it flows, like a river carrying us along. But what if time isn't like a river at all? What if that feeling of constant movement, of moments rushing by, is just how our minds see something much stranger? Think about this. When you remember yesterday, it feels firmly in the past, right? And tomorrow feels like an empty space we're heading towards. We live in this constant now, with the past behind us and the future ahead. This is how we usually understand time. A straight line, always moving forward. This idea of time moving is deeply rooted in our thoughts and how we live. Even ancient Greek thinkers like Aristotle saw time unfolding through movement and change. But here's the thing. Some scientists and thinkers suggest that maybe the past, present, and future all exist at the same time. Not magically, but physically. Think of a map. All the cities, New York, London, Tokyo, they all exist right now, simultaneously. You might travel from one to another, but they don't pop into existence only when you arrive. They are simply always there. So, imagine time like a vast, unchanging landscape, not a moving river. Every second, every minute, every year from the universe's start to its end is already there. Like points on a huge map, our consciousness, our now, is like a spotlight moving across this landscape. It shines on one point, then the next, giving us the feeling we are moving through time. But the points themselves, past, present, future, are all fixed. This idea is called the block universe theory. It comes from Albert Einstein's work on relativity. He showed that time and space are woven together into something called space-time. In space-time, there isn't a special now that applies to everyone. Your now could be different from someone else's, especially if they're moving very fast or are near a huge gravitational pull. This makes it hard to think of time as a single, flowing river for everyone. If time is relative, if now is different for different people, then the idea of a single, moving present moment breaks down. Think of it like a movie reel. When you watch a movie, you see frames one after another, creating the illusion of movement. But if you take the film out, all the frames, the beginning, middle, and end, are already there on the strip, existing at once. The whole story is complete, start to finish, even before you press play. Our experience is like the projector, showing us one frame at a time, making it seem like time is passing. This way of seeing time can be a bit mind-bending. It means the moment you're reading this, the moment you ate breakfast, and the moment you'll go to sleep might all be equally real in the universe. They just exist at different points in space-time, and our minds travel through them. If time isn't flowing, but just is, what does that mean for us? It might make you think differently about worries about the future, or regrets about the past. Perhaps those moments aren't gone forever, or coming towards us, but simply are. It leaves us with a deeper sense of wonder about the universe, a mystery that unfolds not just through change, but through a vast, silent presence holding all moments within it. It's a quiet thought, one that can make the ordinary flow of minutes feel like a profound journey through an unchanging eternal landscape. How our brains make us see colors. Have you ever really stopped to think about color? Not just what your favorite color is, but what color is. We see a bright red apple or a deep blue sky, and we just assume that red and blue are out there, painted onto the world around us. But what if I told you that color isn't actually in the apple or in the sky? What if color is something your brain actually creates? It's a strange thought, but here's the thing. Everything we see, from the brightest sun to the darkest shadow, starts with light. Light travels in waves, kind of like ripples in a pond, but much, much faster. These waves have different lengths, and our eyes are amazing tools that can pick up these different wavelengths. But seeing the light is just the first step. When light hits an object, like that red apple, something interesting happens. The apple doesn't have redness inside it. Instead, the surface of the apple absorbs most of the light waves that hit it. It sucks up the blue ones, the green ones, the yellow ones, but it rejects, or reflects, the light waves that match what we call red. So, only the red light waves bounce off the apple and travel toward your eyes. Once those reflected light waves reach your eyes, they hit special cells in the back of your eye called cones. You have millions of these cones, and they are like tiny antennas, tuned to pick up different types of light. Some cones respond strongly to what we call red light, some to green light, and some to blue light. These cones then send electrical messages, like tiny coded signals racing up the optic nerve and straight to your brain. And this is where the magic really happens. Your brain takes these raw electrical signals, these bits of information from your eyes, and it processes them. It combines them, interprets them, and then, almost instantly, it creates the experience of red. That red, you see? It's not out there in the apple itself. It's a feeling, a perception, a vivid creation happening right inside your head. The apple only reflects the light. Your brain gives it color. Think about it like listening to a song. The sound waves themselves are just vibrations in the air, but your ear captures those vibrations, sends signals to your brain, and your brain transforms those simple vibrations into the rich melodies and harmonies you hear. You don't just hear vibrations, you hear music. In the same way, you don't just see light waves, you see color. This idea isn't new. For centuries, thinkers have wondered about what is real and what is just in our minds. Long ago, a famous scientist named Isaac Newton used a prism to show that white light is actually made up of all the colors of the rainbow. He separated the light, but he understood that the colors themselves were not just floating in the air. Later, philosophers like John Locke suggested that things like color, sound, and taste aren't truly part of the objects themselves, but are secondary qualities that our minds create when we interact with those objects. So, when you gaze at a beautiful sunset, filled with oranges and purples, remember that those breathtaking hues are not just painted across the sky. They are being painted, moment by moment, within the incredible, quiet darkness of your own mind. Your brain is a masterful artist, constantly interpreting the world, transforming invisible light waves into the vibrant tapestry of color that fills your life. It's a subtle reminder of how much of our reality is, in a way, a dream we conjure for ourselves. And that makes the world, and our place in it, even more wonderfully mysterious. The unseen energy all around us. Have you ever walked into a room and felt a sudden shift in the air? Maybe a sense of calm or perhaps a strange tension, even if no one said a word? Or have you stood in an ancient forest and felt a profound quiet, a deep presence that seemed to whisper from the very trees? That feeling, that deep sense of something present but invisible, points to a concept people have wondered about for thousands of years: unseen energy. This isn't just about electricity or heat. It's about something more subtle, something that our regular senses can't quite pick up. It's the idea that there are forces, vibrations, or connections all around us that we can't easily measure with our tools. Imagine a giant, invisible ocean, and everything in the world is floating within it. This ocean isn't made of water, but of pure energy, pulsing and flowing constantly. We are part of it, and it flows through us. For thousands of years, people across the world have talked about something like this. In ancient China, they called it qi, a life force, a vital energy that flowed through everything, from the human body to the natural world. They believed this qi affected health, mood, and even luck. In India, a similar idea was called prana. These weren't just made-up stories. They were attempts by wise people to understand how the world worked, how life happened, and why things felt connected in ways that were hard to explain. Even today, some scientists explore ideas of energy fields that connect living things, moving beyond what standard physics currently fully understands. Think about how you feel when you are near different people. You might have a friend who always seems happy and bright, and just being around them makes you feel lighter. Then there's someone else who always seems grumpy or sad, and being near them can make you feel drained, even if they don't say much. It's like their mood, their inner state, creates an invisible ripple, and you are feeling that ripple. We often call this a vibe, but what if it's more than just a feeling in our minds? What if it's truly an energy we are picking up on? A subtle hum from another person's being, or from the very atmosphere of a place. Another way to think about it is like a magnet. You can't see the magnetic field, right? But you know it's there because it pulls on metal objects. It's an invisible force, but its effects are very real. What if there are many other kinds of invisible forces, or energies, that surround us and subtly influence our world, just like a magnet affects metal? These energies might be why you sometimes get a sudden feeling of dread or joy without a clear reason. They might be why certain places feel calming and others feel unsettling. Our brains might be wired to sense these subtle waves, even if we don't always understand what they are. This idea that there are energies beyond what our normal senses can easily detect is truly amazing. It invites us to consider that reality might be far grander, much more mysterious than we usually think. It makes the world feel deeper, more alive. And perhaps, as you drift off to sleep tonight, you can feel a little more connected to this hidden, pulsing world, understanding that you are always part of something vast and truly unexplainable. Planets that wander lost in space. Have you ever thought about what it would be like to have no home, to just drift, alone, with nothing to guide you? In the vast, silent ocean of space, there are planets that do just that. They are like cosmic wanderers, forever lost, unbound by the pull of a star. These are called rogue planets, and they are one of the universe's most mysterious, unexplainable science phenomena. Here's the thing. For a long time, we always believed that a planet needed a sun. We thought planets formed from the swirling dust and gas around a young star, and then stayed forever in orbit, warmed and lit by its light. Our own Earth, with its perfect dance around the sun, is a good example of this. But then, as our telescopes got better and our ways of looking at space became more powerful, we started to see hints of something different. Scientists began to realize that the universe might hold many worlds that don't fit our usual picture. So, what exactly is a rogue planet? It's a planet that doesn't orbit any star. It's like a boat that has broken free from its dock and is now adrift in a huge, dark ocean with no land in sight. These planets simply float through interstellar space, the vast emptiness between star systems. They are alone, cold, and dark, lit only by the faint glow of distant galaxies, or perhaps some leftover heat from their own formation. How does a planet end up like this? Scientists have a few ideas. One common theory is that these planets were once part of a star system, just like Earth. But something big happened. Maybe they had a really close encounter with a massive giant planet like Jupiter in their early solar system. The gravity of that big planet could have acted like a slingshot, flinging the smaller planet right out of its home system, sending it speeding into the cold, dark void. Think of it like a game of cosmic billiards, where one ball gets knocked off the table entirely. Another idea is that some of these planets might have formed directly in space, far away from any star, from clumps of gas and dust that never quite gathered enough material to become a star themselves. The existence of these rogue planets changes how we think about life in the universe. If a planet doesn't have a star, how could anything survive there? It would be incredibly dark and freezing cold, far colder than anything we experience on Earth. But here's an interesting thought. Some scientists wonder if these rogue planets could still hold liquid water under thick ice shells, heated by their own internal core, just like some moons around Jupiter and Saturn. If that's true, then maybe, just maybe, life could exist in places we never imagined, far from the warmth of any sun, and that's why they are so fascinating. They challenge what we thought we knew about planets and how they work. They are silent, dark witnesses to the universe's wild and unpredictable nature. Their existence reminds us of the endless possibilities in the cosmos, of worlds truly lost and alone, yet still somehow existing, still part of the grand, silent story of everything. It's a quiet, humbling thought. How much is out there that we still don't fully understand, drifting in the quiet, endless dark. The Bermuda Triangle's deep secret. Have you ever looked at a map, or perhaps at the vast, dark ocean, and wondered about its deepest mysteries? Imagine a place on Earth where ships vanish without a trace and planes disappear from the sky. No distress calls, no wreckage, just gone. This is the enduring mystery that surrounds a part of the Atlantic Ocean known as the Bermuda Triangle. For centuries, stories have whispered about this strange area. It's not a perfect triangle, but more of a rough region in the western part of the North Atlantic. If you were to draw lines connecting Bermuda, Florida, and Puerto Rico, you'd roughly outline its boundaries. Sailors and pilots have reported unusual happenings here for hundreds of years. Compasses spinning wildly, radios going silent, strange lights in the sky, or sudden violent storms appearing out of nowhere. The most chilling part is the silence afterward. It's like the ocean simply swallowed them whole. Many of these stories began gaining wide attention in the middle of the last century. There was the mysterious disappearance of Flight 19, a group of 5 U.S. Navy planes on a training mission in 1945. They simply vanished. Then, the rescue plane sent to find them also disappeared. Neither the planes nor their crews were ever found. Think about that for a moment. Advanced aircraft, trained pilots, and an entire search party, all swallowed by the unknown. Before that, even huge ships like the USS Cyclops, a U.S. Navy collier with over 300 people on board, disappeared in the area during World War I, leaving no trace. These aren't just old legends. They are real events that left real families wondering. So, what's going on? Scientists and experts have looked at many ideas. Some suggest it's simply a very busy part of the ocean, where lots of traffic means more chances for accidents. The weather in that region can be harsh and unpredictable, with sudden, powerful storms and rogue waves, those incredibly huge waves that appear from nowhere. The ocean floor in the triangle also has very deep trenches, like the Puerto Rico Trench, which is one of the deepest spots in the Atlantic. If something sinks there, it could fall miles down, making it almost impossible to find. There are also theories about natural forces. For example, some parts of the ocean floor contain something called methane hydrates. This is basically frozen gas. If these gas pockets suddenly burst or melt, they could release massive bubbles of gas. Imagine giant gas bubbles rising to the surface. A ship caught in one of these would lose its buoyancy and sink incredibly fast, almost like falling through a trapdoor. A plane flying through such a sudden, violent updraft of gas could also face extreme turbulence or engine failure. It's like when you see a big pot of water boiling, and the bubbles suddenly get much bigger, churning everything up. The ocean, in its vastness, holds many such secrets, hidden in its depths. But here's the thing. While these scientific explanations offer possibilities, they don't fully explain every single disappearance. There are still cases where conditions seem normal, yet vessels and aircraft vanished. This leaves us with a quiet sense of wonder. The Bermuda Triangle reminds us that even with all our knowledge and technology, there are still parts of our world that remain deeply mysterious. It's a vast, powerful planet we live on, and sometimes nature simply operates on a scale we can barely comprehend. The unknown doesn't have to be scary. Sometimes, it's just a reminder of how much more there is to learn, how much more there is to quietly observe and appreciate about the great, wide world around us. It's a soft mystery, inviting us to simply wonder. Why does gravity feel so odd sometimes? Have you ever felt that weird lurch in your stomach when an elevator starts going down really fast? Or when you're at the top of a roller coaster and it suddenly drops. For a split second, it feels like gravity just vanished. Or maybe it felt like it pulled you extra hard, pressing you down into your seat. That feeling can be so odd, almost confusing. But here's the thing. Gravity itself wasn't actually changing in those moments. It's always pulling on you, every single second. So, what's going on? Gravity, at its simplest, is an invisible force. It's what pulls everything with mass or energy towards everything else with mass or energy. The earth pulls you down, keeping your feet on the ground. You, tiny as you are, pull the earth up a tiny bit too. It's happening all the time, everywhere in the universe. For hundreds of years, people mostly just knew that things fell. Isaac Newton, a brilliant scientist from a long time ago, gave us rules for how gravity works. He showed us that the same force that pulled an apple from a tree also kept the moon circling our planet. It was an amazing discovery, making so much of the universe make sense. Then, centuries later, another incredible thinker named Albert Einstein came along. He looked at gravity in a whole new way. Instead of just a pulling force, he said gravity was more like the universe itself being a giant, flexible sheet, like a trampoline. If you put something heavy on that trampoline, like a planet or a star, it makes a dip or a curve in the sheet. And other, lighter things, like us, don't get pulled into that dip. Instead, we just roll along the curve. We're simply following the shape that massive objects create in space and time. This idea that space itself is warping is how Einstein explained gravity. It's a beautiful, elegant way to see it. So, when does gravity feel odd? It's often when something else is also moving or stopping quickly. Think about when you're in a car, and the driver suddenly slams on the brakes. Your body gets pushed forward. You feel heavier, maybe, or like you're being squashed. That's not gravity pulling more on you. That's your body trying to keep moving forward, and the car stopping fast. Your perception of weight changes, even though the Earth's pull on you hasn't changed at all. Our bodies are incredibly sensitive to changes in motion. When an elevator speeds up or slows down, your inner ear, your muscles, all of you feel those changes. It's like your body is trying to catch up or slow down with the motion, and that creates those strange sensations of being heavier or lighter. It's not gravity itself changing, but your perception of it, based on how you're moving or stopping. But even with Newton's rules and Einstein's warping space-time, the deepest mystery of gravity still remains. We can describe what it does. We can predict its effects with incredible accuracy. But what it actually is, its fundamental nature still has layers we don't fully understand. It's different from other forces, like magnetism or electricity. We can't really turn off gravity or easily block it. It's just there, everywhere. It acts on everything, all the time, shaping stars, guiding planets, and keeping us right here on Earth. So, when you feel that strange sensation on a roller coaster, in a fast elevator, or even just stepping off a curb, remember, it's a small window into one of the universe's biggest puzzles. It's a reminder that even the most common things, like the force holding us to this planet, hold deep secrets. It makes you realize how much wonder is hidden in plain sight, pulling us softly, constantly, into the great unknown, even as we feel its familiar, sometimes odd, embrace. The green flash at sunset and sunrise. Have you ever watched the sun slowly disappear below the edge of the world? A fiery orange ball sinking into the vast ocean or behind distant mountains. It's a moment many people cherish, a beautiful end to the day. But what if, just as the last sliver of sunlight vanished, you saw a tiny, bright flash of green light? Not an imagined light, not a trick of your eyes, but a real, vibrant green spark. This is the green flash, a scientific marvel that many people have heard of, but very few have actually seen. For a long time, the green flash was a bit of a mystery, almost like a legend told by sailors or adventurers who spent a lot of time on the open sea. They would whisper about seeing this quick, emerald flicker right at the moment the sun finally set. Some thought it was a sign, or a rare lucky sight. In stories from the past, sometimes these moments were thought to be magical. But like many natural wonders, science eventually came along to explain this fleeting, beautiful event. It turns out the green flash isn't magic. but it is certainly extraordinary. So, how does this happen? Think about light for a moment. We see white light from the sun, but that white light is actually made up of all the colors of the rainbow: red, orange, yellow, green, blue, indigo, and violet. You know this if you've ever seen a rainbow, where raindrops act like tiny prisms, splitting the sunlight into its different colors. Our atmosphere, the layer of air around our planet, can do something similar, especially when the sun is very low in the sky, like at sunset or sunrise. When sunlight travels through our atmosphere, it bends. This bending is called refraction. It's like when you look at a straw in a glass of water, and it seems to bend or break where it enters the water. The light from the sun does something similar as it enters our atmosphere. Different colors of light bend at slightly different angles. Blue and violet light bend the most, and red and orange light bend the least. Because blue light bends so much, it often scatters away or gets absorbed by the atmosphere before it even reaches your eyes when the sun is low. Red and orange light, which don't bend as much, are usually the last colors we see as the sun sets. But green light, which sits right in the middle of the spectrum, sometimes gets a special chance. Just for a quick second, as the very top edge of the sun disappears, all the other colors might be gone, scattered, or already below the horizon. For that tiny moment, conditions are just right for the green part of the sun's light to be the very last ray you see before it fully vanishes. It's like the atmosphere is filtering out all the other colors, leaving just a sliver of green to shine through right at the very end. Seeing a green flash requires perfect conditions: a clear horizon, no clouds, and clean air. It's a very quick event, lasting only a second or two, maybe even less. It's so quick that if you blink, you might miss it. This fleeting nature makes it feel even more special when it does happen. It's a reminder that even in things we see every day, like a sunset, there can be tiny, hidden wonders waiting to be discovered if we just pay close enough attention. It tells us that beauty isn't always big and obvious. Sometimes it's in the blink of an eye, a whisper of color, a quiet moment that makes us feel connected to the vast, amazing world around us. It's a brief, emerald goodbye, or a hopeful green hello that reminds us of the delicate and astonishing dance of light and air that constantly surrounds us. Creatures that glow in the dark deep. Imagine a place so dark, so completely without light, that your eyes are useless. A place where the sun has never touched, not even a single ray. What kind of life could exist there? And how would they even find each other, or food, or simply know where they are going? This is the deep ocean, a world stranger than anything we can truly picture. And yet, it is filled with creatures that carry their own light. They glow. This amazing ability is called bioluminescence. It's not magic, but it feels a lot like it. Think about a firefly on a summer night, blinking its tiny light. That's bioluminescence. But in the deep sea, it's not just a few small bugs. It's a whole world of living lights. These creatures, from tiny jellyfish to strange-looking fish, make their own light through a chemical reaction happening inside their bodies. It's like they have little living light bulbs built right in. Why do they do this? Here's the thing. In a place with no light from the sun, having your own light is incredibly useful. Some use it to hunt. A deep-sea anglerfish, for example, has a natural fishing rod that dangles a glowing lure right in front of its mouth. Other fish, curious about the light, come closer, and then, well, it's too late for them. Others use their glow to hide. Imagine you're a tiny shrimp. If you glow from your belly, a predator looking up from below might mistake your light for the faint glow of the surface, helping you disappear into the vastness. And sometimes, they use light to talk to each other, like a secret code in the dark, signaling for mates or warning off rivals. It's truly a world beyond our understanding, this glowing dark. For most of human history, we didn't even know these creatures existed. People used to think the deep ocean was just a cold, empty void, a silent bottom of the world. But then, as our technology improved, we built special submersibles, like tiny submarines, that could withstand the incredible pressure of the deep. And that's when we started to discover this hidden, glowing universe. It was like finding an entire city of stars buried beneath the waves. Think about walking into your bedroom late at night. It's completely dark. You can't see a thing, But then you turn on your phone screen, and suddenly, a small part of the room is lit. You can see your hand, maybe a corner of your bed. Now imagine if your hand, and your bed, and maybe your clothes, could all just glow on their own, softly, without needing a battery or a plug. That's a little like what it's like for these deep-sea creatures. They are light-bearers in a world of endless night, creating their own visibility, their own pathways. It makes you wonder, doesn't it? How life can find a way, no matter how harsh the conditions. In the crushing darkness, under immense pressure, and in freezing cold, life doesn't just survive. It thrives. It adapts in ways we can barely imagine, like learning to carry its own tiny sun. These glowing creatures remind us that the universe is far more inventive and mysterious than we often think. There's a quiet beauty in knowing that even in the deepest, darkest places, there is light. And sometimes, that light is alive, and breathing, and just existing. A silent testament to the endless wonder of our world. When mountains sing their own song, have you ever been completely quiet, listening, and then heard something amazing? Maybe the soft rustle of leaves, or the far-off sound of thunder. But what if you heard a deep, humming sound coming from a giant pile of sand, like a mountain singing to itself? Sounds like something out of a fantasy story, right? But here's the thing. It's a real mystery in our world. This strange happening is often called singing sands or booming dunes. Imagine standing in a vast desert, surrounded by huge dunes, sometimes hundreds of feet high, and then, without warning, a low, deep note begins to hum. It's not the wind. It's not an animal. It's the sand itself, making a sound so strong you can feel it vibrate through your feet. Some people say it sounds like a pipe organ, others like distant thunder, or even a low groan. Scientists have been puzzled by these singing sands for a long time. For hundreds of years, travelers and explorers wrote about hearing these mysterious sounds in deserts across the globe, from China to the Sahara. Some thought it was the spirits of the desert, or maybe warnings from unseen beings. The famous traveler Marco Polo, way back in the 1200s, wrote about hearing the sounds of all kinds of musical instruments from the sand dunes in Central Asia. People didn't have scientific explanations then, so they imagined fantastical reasons for what they heard. But here's what scientists have found so far. The sound comes from the sand grains themselves. When a large amount of sand slides down a dune, the grains rub against each other. It's a bit like when you rub your hands together really fast. You feel heat. With sand, this rubbing creates vibrations. These vibrations can cause the air caught between the sand grains to shake at a certain speed, making a sound. It's like how a guitar string vibrates and makes a musical note. The size of the sand grains, how dry they are, and how fast they move all seem to affect the sound. Sometimes, a whole dune can hum together, like a giant natural choir. But here's the problem. We still don't fully understand it. Why do only some sand dunes sing, and not others? Why do they make such clear musical notes, instead of just a noisy rumble? Scientists have even tried to make sand sing in labs, but it's really hard to get it to sound like the powerful hums you hear in the desert. It's almost as if the dunes need to be alive in their natural environment to truly sing their song. It makes you wonder what other secrets the earth holds, waiting for us to listen closely. Think about it this way. When you run your finger around the rim of a crystal glass, it can make a beautiful, clear, ringing sound. The glass doesn't have a voice, but when the right conditions are met, the friction of your finger, the way the glass vibrates, it sings. Now imagine that on a massive scale, with billions of tiny sand grains working together to create a sound that can travel for miles. It's a reminder that even the quietest, most ancient parts of our world can hold astonishing secrets. And so, as we drift off to sleep, maybe we can imagine those ancient dunes softly humming their mysterious lullabies under the desert moon. It reminds us that there's so much more to discover, even in things we think we know. The world is full of hidden music, waiting for us to slow down, listen, and simply wonder. And that's a beautiful thought to carry into our dreams. The puzzling nature of consciousness. Have you ever just stopped for a moment and truly thought about what it means to be you? Not just your body, but the inner part of you that sees, feels, dreams, and thinks. That private world inside your head, where your thoughts buzz and your feelings rise and fall. This amazing, mysterious thing we're talking about is called consciousness. It's what makes you aware that you exist, aware of the world around you, and aware of your own unique experiences. It's the feeling of understanding a joke, the warmth of a hug, the memory of your first day of school. For a very long time, people have wondered about consciousness. Ancient thinkers, wise people from long ago, would sit and ponder it. They asked, where do our thoughts come from? Is our mind separate from our body? If a tree falls in a forest and no one is there, does it still make a sound? These big questions are still with us today, even with all our incredible science. Because here's the thing, while we know a lot about the brain, how neurons fire, how different parts light up when we think or feel, we still don't fully understand how all that physical activity creates your personal living experience. Think about it like this. Your brain is an incredibly complex computer. It processes information. It stores memories. It controls your body. We can see its parts, how blood flows, and even measure electrical signals. But can a computer feel the joy of winning a game? Can it miss a friend? No, not in the way you do. That's because consciousness isn't just about processing facts. It's about having an inner life, a personal perspective. It's the difference between a robot seeing the color red and you experiencing the vibrant warmth of a sunset. The robot can name the color, but it doesn't feel it. You do. This difference is what makes consciousness so puzzling to science. We can study the brain, map its connections, and even understand how certain injuries can change a person's thoughts or memories. But how does that collection of cells and chemicals create the actual sensation of pain, or the deep feeling of love, or the quiet wonder of looking up at the stars? Scientists call this the hard problem of consciousness, because it seems to go beyond just understanding how the brain works. It's about understanding how something physical can become something deeply personal and non-physical, like your awareness. So, as you drift off to sleep tonight, remember this incredible mystery you carry within you. Consciousness is one of the universe's greatest secrets, hidden not in a distant galaxy, but right inside your own head. It's what allows you to dream, to imagine, to learn, and to simply be. And while we don't have all the answers, just knowing that this profound puzzle exists, and that you are living proof of it, is a truly amazing thought to rest upon. It's a quiet wonder, always there, always thinking, always feeling, even as the world sleeps. Rivers that just disappear underground. Have you ever stopped to think about how much we really see of the world around us? We look at a river, flowing strong and steady, winding its way across the land. It seems so permanent, so unchanging. But what if that river, that powerful ribbon of water, simply vanished? One moment it's there, gurgling and rushing, and the next, it's gone. It just disappears, sinking into the ground as if it were a dream. This isn't a fantasy or a magic trick. This is a real, unexplainable phenomenon that happens in many places across our planet. Rivers that just disappear underground are called sinking rivers or lost rivers. Here's the thing. They don't just evaporate into thin air. They find a secret path, a hidden entrance into the earth itself. Imagine a giant natural plumbing system hidden beneath our feet. Over long stretches of time, water, which is surprisingly good at dissolving certain types of rock, especially limestone, carves out tunnels and caverns. It's like a slow, patient sculptor. Rainwater, slightly acidic from the air, seeps into cracks in the rock. Over thousands, even millions of years, these tiny cracks become bigger, forming elaborate networks of underground caves and channels. When a river flows over an area made of this kind of soft, porous rock, it can find one of these natural openings. It then plunges down, sometimes into a vast, dark cave, sometimes into a narrow crack, vanishing from our sight. It's like when you drain a bathtub. The water seems to vanish, but you know it's just going down the drain and into the pipes. With a sinking river, the drain is a giant hole in the earth, and the pipes are miles of natural tunnels and caverns we can barely imagine. This type of landscape, with its disappearing rivers, sinkholes, and caves, is called karst topography. It's a testament to the quiet power of water, working tirelessly shaping the world in ways we rarely see. For people long ago, these disappearing rivers must have been truly baffling. They didn't have geology, textbooks, or scientific instruments. They might have thought spirits or monsters dragged the water away, or that it was a gateway to another world. It teaches us something important. The world is full of things that operate on a scale much grander than our everyday lives. What seems sudden or impossible to us is often just the visible part of a very slow, very long natural process. Think about a secret passage in an old castle. You walk along a wall, and suddenly, a stone pivots, revealing a hidden room or staircase. That secret passage was always there, built into the structure, just waiting to be discovered. Sinking rivers are like that. The path underground has been forming for ages, hidden in plain sight, until the water finds its way in. And that's why it matters. Even with all our science, there's still so much we don't know about these hidden journeys. Where do all those rivers go? Do they join vast underground lakes? Do they resurface miles away, perhaps cleaner, perhaps muddier? Sometimes they do reappear, gushing out of a hillside somewhere, proving their mysterious journey. But often, they don't, or at least not in a way we can easily trace. This quiet disappearance of mighty rivers reminds us that our world is deeper and more mysterious than it appears on the surface. There are vast, unseen realms, intricate pathways that exist just beyond our view. It's a gentle whisper from the earth, telling us to look closer, to wonder about the hidden journeys, and to feel a sense of calm awe for all the quiet, powerful things that happen in the shadows beneath the world we think we know. It's a reminder that even the most visible things can have a secret life, flowing onward, out of sight, in ways we can only imagine. Those weird clouds that spin forever. Have you ever looked at something in nature and wondered how it just keeps going? Like a whirlpool in a creek that spins and spins without ever really stopping, or a top that seems to defy gravity, just whirling on and on. There are things in our world that act like those spinning tops, especially some really strange clouds. We call them clouds that spin forever. Not because they literally last forever, but because they hold together, in their own way, for much longer than they should. They are truly odd, and science still has a lot of questions about them. Imagine a cloud, not like the fluffy white ones you see on a sunny day, but a long tube-shaped cloud that stretches across the sky for hundreds of miles. And this cloud isn't just sitting there, it's rolling forward, like a wave in the ocean, but in the air. This is a real thing, called a morning glory cloud. It's mostly seen in one place on Earth, over the Gulf of Carpentaria in Australia. These clouds are giant, long rolls of air that actually spin along their length. They can be miles high and can travel for hours, even days, before finally breaking apart. Here's the thing. Most clouds form, change shape, and then just disappear. They mix with the air around them and fade away. But these morning glory clouds, and other similar strange atmospheric happenings, seem to keep their shape and their energy. They're like a perfect balance of forces that allows them to stay together. Think about a ripple in a pond. It spreads out and eventually vanishes. But some of these cloud formations are like a ripple that just keeps going, keeping its exact form. Scientists have studied them for a long time. They've used planes and special instruments to measure what's happening inside them. But even with all that work, understanding exactly how they form and stay stable for so long is still a puzzle. It's like finding a perfect spiral in a seashell and trying to figure out every tiny step of how it grew that way. In ancient times, people might have seen sights like these morning glory clouds as signs from the gods, or powerful spirits traveling across the sky. They didn't have all our scientific tools, so they looked for meaning in what they saw. It makes you think, doesn't it? When something appears to defy the normal rules, our minds naturally try to make sense of it. Maybe it's a mystery. Maybe it's magic. Maybe it's just something we haven't fully understood yet. That's part of the deep human need to explore and learn. We see something strange, and we want to know why. It's like when you try to balance a pencil on its tip. It might wobble for a second, then fall. But if you spin it really fast, it can stand up for much longer. The spinning gives it stability. These clouds might be doing something similar with the air around them, finding a way to stay balanced in a world that usually wants things to mix and fade. It's a beautiful dance between forces, a kind of perfect, swirling system that sustains itself against all odds. So, when you look up at the sky next, even if you don't see a giant rolling cloud, remember that there are hidden movements, unseen forces at play. There are these wonderful, perplexing things that hold together, defying simple explanation. They remind us that the world is full of mysteries, and that's okay. Sometimes, the most beautiful things are the ones we can't quite figure out, the ones that keep spinning in our minds, just like those weird clouds in the sky. They are a soft whisper that the universe still holds so many secrets, waiting for us to wonder about them. What's inside a black hole? Have you ever looked up at the night sky and wondered what secrets the universe holds? Beyond the twinkling stars and distant galaxies, there are places so strange, so powerful, they challenge everything we think we know. One of the most mysterious is the black hole. But what really happens inside one? What's in there? Why I am. Here's the thing. Imagining the inside of a black hole is like trying to picture a place where all the rules we live by on Earth just disappear. A black hole isn't an empty space, though it sounds like it might be. It's actually a place in space where gravity is incredibly, unbelievably strong. So strong that nothing, not even light, can escape once it crosses a certain point. Think about that for a moment. Light, the fastest thing we know, can't get out. That's why they're called black holes. This incredible gravity comes from a lot of matter, like the stuff that makes up stars, squeezed into an impossibly small space. Imagine taking something huge, like a star many times bigger than our sun, and crushing it down until it's smaller than a city. All that mass, all that heavy stuff, packed together, makes the gravity around it just insane. Now, there's a point of no return around a black hole. Scientists call it the event horizon. It's not a physical wall you can see. It's more like an invisible boundary. Think of a giant waterfall. If you're a small leaf floating in the river, you might get close to the edge. But once you go over the edge of the waterfall, there's no going back up. That's kind of what the event horizon is like for anything, even light, that gets too close to a black hole. Once you cross it, you're falling in, and there's no escape. So, what happens after you cross that edge? Well, nobody truly knows for sure, because we can't send anything in and get information back out. But based on our best science, the journey would be truly wild. As you fall deeper, the gravity pulling on your feet would be much, much stronger than the gravity pulling on your head. This would stretch you out like a piece of spaghetti. Scientists even have a name for it: spaghettification. It's a pretty intense way to go. And at the very center, after all that stretching and squeezing, is what physicists call a singularity. This is the part that's hardest to imagine. A singularity is a point in space where all the matter of the black hole is crushed into an infinitely small, infinitely dense point. All the mass of a giant star squished into something smaller than an atom. At this point, our best laws of physics, the ones that explain how the universe works, simply break down. They just don't make sense anymore. It's like trying to divide by zero in math class. The answer is undefined. Philosophically, black holes are fascinating because they represent the edge of our understanding. For centuries, thinkers and scientists have tried to figure out the universe, piece by piece. When Albert Einstein came up with his theory of gravity, it suggested these strange objects could exist. But even he might have been surprised by how bizarre they truly are. They are places where time and space itself get so warped and twisted that our everyday experience of reality just falls apart. So, what's inside a black hole? It's a place of ultimate compression, extreme gravity, and profound mystery. It's where the known universe ends and something entirely unknown begins. And perhaps that's the most beautiful part of it all. It reminds us that there's still so much to discover, so much to wonder about in the deep, silent reaches of space. And maybe, just maybe, some secrets are meant to remain secrets, beckoning us to keep dreaming and asking questions. The way trees talk without words. Have you ever walked through a quiet forest and thought about how still everything feels? Just trees, standing tall, barely moving. We often think of them as silent, lonely giants. But What if I told you that beneath the ground and even through the air, trees are constantly having conversations? Not with words like we do, but with secret messages, sharing important information about their lives. It sounds strange, right? Like something out of a science fiction movie. But here's the thing. Scientists have found that trees are deeply connected. They use something called a wood wide web. Imagine a massive natural internet hidden underground. This web is made of tiny threads called mycelium from fungi. These fungi link up the roots of many different trees, even trees of different kinds. Through these fungal highways, trees can send chemical signals to each other. Think of it like this. If one tree is being attacked by bugs, it can send out a chemical warning. This warning travels through the fungi to other trees nearby. It's like shouting, "Watch out, pests are coming." When other trees get this message, they might start making chemicals to protect themselves, even before the bugs reach them. It's an early warning system, but it's not just about danger. Trees also share resources. Imagine a group project in school. One person finishes their part early, or maybe someone else is struggling and needs help. In a good group, you share your notes or offer to help them catch up. Trees do something similar. If one tree is getting plenty of sunlight and making a lot of food, it might send some of its extra nutrients, like sugars, through the fungal network to a younger, smaller tree that's struggling in the shade, or to a sick tree that needs a boost. It's a silent, secret act of kindness, a helping hand without a sound. And it's not just underground. Trees can also send messages through the air. When certain insects chew on a tree's leaves, the tree releases special chemicals into the air. These chemicals can float to nearby trees, telling them, "Hey, something's eating me." This airborne signal can also trigger defenses in other trees. For a long time, we just saw trees as separate, competing individuals. We thought each tree was just trying to get all the light and water for itself, battling its neighbors. But now, we're starting to understand that they're much more connected, much more cooperative than we ever imagined. This idea of trees communicating and helping each other is still pretty new. It changes how we think about nature. Why do they do this? Why would a tree share its precious resources with another tree, even one that isn't its family? It doesn't seem to make sense if you think of them only fighting for survival. It suggests a deeper, more complex intelligence, a kind of silent wisdom that we are only just beginning to understand. It's not fully explainable by just looking at individual trees. It hints at a natural system that works together in ways that go beyond simple competition. So, next time you see a forest, or even just a single tree, remember this hidden world. Think about the quiet connections happening all around us, even in the most unexpected places. It reminds us that maybe everything is connected in ways we can't always see or hear. The trees, those silent giants, teach us a deep lesson about cooperation, about sharing, and about supporting each other, even without a single spoken word. Their silent conversations whisper a truth. We are all part of a larger, interconnected web, and there's profound strength in working together, even when we don't understand all the reasons why. The mystery of your own memories. Have you ever stopped to really think about your memories? Not just what you remember, but how you remember it. Like that amazing feeling of recalling a funny moment with a friend, or remembering exactly what happened on your last birthday. But then other times, you try really hard to remember something simple, like what you ate for lunch 2 days ago, and it's just gone. It's strange, right? Why are some memories crystal clear, while others vanish like mist? Here's the thing. Memory isn't like a video recorder in your brain. It's not just playing back a perfect movie of what happened. Our memories are much more complicated and, honestly, a little mysterious. When you remember something, your brain isn't just pulling up a file. It's actually rebuilding that experience, putting pieces together. And sometimes, those pieces can be influenced by how you feel, by what you've learned since, or even by what other people tell you happened. For a long time, people have tried to figure out how memory works. Ancient thinkers, like the famous Greek philosopher Plato, thought memory might be like pressing a seal into a block of soft wax. The experience would leave an imprint, and that imprint was the memory. Later, people imagined the brain as a giant library, with each memory neatly filed away on a shelf. You just go to the right shelf and pull out the book. But the more we learn about the brain, the more we realize it's not that simple. It's far more active and creative than just a storage space. So, where do memories actually live? Scientists believe memories are stored in the tiny, intricate connections between billions of brain cells called neurons. When you learn something new or experience something, these connections change and strengthen. They form complex networks. But exactly how these electrical and chemical signals magically turn into a clear picture or feeling you can recall, and then keep it stored for years, even decades, is still a huge puzzle. Think about a time you tried to remember something, like a specific detail from a movie you saw a long time ago. Maybe you were sure the main character wore a red hat, but then your friend says it was blue. And when you check, your friend was right. How could your memory feel so strong, so real, yet be wrong? This happens all the time, even with important things. For example, in court cases, eyewitnesses sometimes describe things that didn't happen exactly as they remember them. They aren't trying to lie. Their memory genuinely believes what they saw. It shows how tricky and changeable memory can be. This is one of the most amazing and perplexing parts of our own minds. Memories aren't fixed. They can change over time, adapt, and even combine with other thoughts or feelings. We might remember a childhood event one way, and years later, after hearing a family story about it, our memory of that event suddenly shifts to include details we never experienced ourselves. It's as if our brain is constantly updating our personal history book. And that leads to a deep question. If our memories can be influenced and even change, then what does that mean for who we are? Our memories are what make us, right? They are our personal story, our experiences, our knowledge. They connect us to our past, to our friends, to our family, and to everything we've ever learned. Yet the very thing that defines us remains a profound mystery, a quiet, constantly evolving landscape within our own minds. It's a beautiful thought, isn't it? To know that inside your head lies a whole universe of experiences, always shifting, always alive. This mystery of memory reminds us how incredible the human brain is. It works in ways we can barely imagine, holding on to moments, shaping our identity, even as it sometimes keeps its deepest secrets hidden. It's a quiet wonder, always there, helping you navigate the world, even if we don't fully understand its magic. Invisible lines that pull our Earth. Have you ever thought about why you don't float away? Or why the moon stays up in the sky, always circling our planet? It's because of something scientists call gravity. Think of it like this. Every single thing in the universe, big or small, has a tiny invisible pull on every other thing. It's like an invisible string or a gentle hand reaching out. The bigger something is, the stronger its pull. The closer two things are, the stronger that pull becomes. That's why Earth, being so huge, pulls on everything near it, keeping your feet on the ground and holding the air around us. For a long time, people just knew that when you dropped something, it fell. It seemed like common sense. But why? This question puzzled thinkers for centuries. Then, a long time ago, a very smart person named Isaac Newton was sitting under an apple tree. Legend says an apple fell and hit him on the head. Instead of just eating the apple, he started wondering, why did it fall down? Why didn't it fly up or sideways? And that simple question led him to figure out a lot about this invisible pull. He realized it wasn't just apples falling, but the same force that keeps the moon orbiting the Earth, and the Earth orbiting the sun. It changed how we saw the entire universe, showing us that the rules that make an apple fall also make planets orbit. So, here's the thing. We can see gravity working everywhere. When you jump, you come back down. When you throw a ball, it arcs and lands. That's gravity at work. It's what holds our solar system together, keeping all the planets dancing in their paths around the sun. Without it, everything would just drift off into space. We can measure gravity. We can predict exactly how fast something will fall or where a rocket needs to go to escape Earth's pull. We use it to calculate satellite orbits and guide probes to distant planets, sending them right where they need to go, relying on this invisible pull. We can even use its pull to speed up spacecraft on long journeys, like a slingshot around a planet. But here's the mystery. the part that keeps scientists thinking late into the night. Even though we know what gravity does, and we know how to use it for incredible things, we still don't fully understand what it is. Imagine you see someone pulling a rope, and you see the box moving. You understand the effect of the pull. But what if you couldn't see the rope? Only the box moving. You'd know there's a pull, but you wouldn't see the actual mechanism. That's a bit like gravity. Is it a tiny particle that creates the pull, moving between objects? Is it like a warp or a bend in the very fabric of space and time itself, where heavy objects create a dip, and lighter objects roll into that dip like marbles on a stretched trampoline? Scientists have big, complex ideas about what it might be, but they haven't quite figured it out yet. They're still searching for the invisible thread that truly makes it work at its deepest level. It's a strange thought, isn't it? The most basic, fundamental force holding our world together, keeping us from floating off into the vastness of space, is still a secret in many ways. It's always there, always pulling, yet it remains unseen and not fully understood. It reminds us that even the things we interact with every single day, the things we take for granted, hold deep mysteries. The ground beneath our feet, the air we breathe, the moon in the night sky, they are all shaped by something powerful and unseen. This invisible force, gravity, is a quiet reminder of how much wonder there is in our world, and how much there is still left to explore and learn. It shows us that even the most ordinary parts of our lives can hide amazing questions. It just sits there, patiently holding everything together. A silent, powerful enigma that we live with every moment, reminding us there's always more to discover, even in the very fabric of our existence. Why some people heal super fast. Have you ever wondered why some people seem to bounce back from injuries or sickness much faster than others? Maybe you know someone who gets over a cold in a day, while it takes you a week. Or perhaps you've seen someone recover from a twisted ankle or a scraped knee at what feels like light speed. It's like their body has a special, secret power to mend itself in record time. This ability to heal quickly is one of those deep, unexplainable science phenomena that makes us pause and think about the true mysteries within us. Our bodies are amazing machines, constantly working to fix and rebuild themselves. When you get a cut, tiny cells rush to the rescue, forming new skin and closing the wound. When you catch a bug, your immune system kicks into high gear, fighting off the invaders. This whole process is called healing, and it's happening inside us all the time, even when we're just sitting still. But for some, this natural repair crew seems to have a built-in turbo button. For centuries, people have been curious about this. Ancient thinkers and healers often spoke of a person's vitality or inner life force. They noticed that some individuals just seemed to have more of it, recovering faster from illness or injury, bouncing back stronger. It was almost as if their bodies held a brighter, more active energy that helped them mend. This wasn't just a scientific observation. It was a philosophical one, a wonder about the hidden strengths within us. Imagine two friends, both the same age, who both fall and scrape their elbows on the sidewalk. It's the same kind of scrape, the same kind of fall. But for one friend, the wound starts to scab over quickly, the redness fades in just a couple of days, and soon, it's barely a mark. The other friend's scrape might take much longer to heal. It might stay redder, feel more sensitive for what seems like forever. Even with the same care, the same bandages, their bodies respond differently. Why is that? They eat similar foods, live in the same town, go to the same school, and yet their internal repair systems work at different speeds. This is where the mystery deepens. Scientists understand a lot about how healing works at a tiny cellular level. They know about how cells divide and rebuild tissue, how blood clots form, and how inflammation helps clear out damaged areas. But they don't fully grasp why some bodies are just naturally more efficient at these processes. Is it purely about our genes, like having a faster healing gene? Maybe, but it doesn't explain everything. Is it about what we eat, how much sleep we get, or how stressed we are? These things definitely play a role, helping or hurting the healing process. But even when you look at people who seem to live very similar lives, with similar diets and stress levels, you still see these striking differences in how quickly they recover. It's like some people's inner repair crews are just wired to be more effective, more resilient, and we don't quite know why. Some people even wonder if our thoughts and feelings play a bigger part than we realize. Could a calm mind or a positive attitude somehow send signals to our cells, telling them to work faster and more efficiently? The mind-body connection is another vast area of science that we are only just beginning to truly understand. Perhaps the inner peace or resilience of a person contributes to their body's ability to mend itself with surprising speed. We don't have all the answers. It's one of those quiet puzzles that makes you think about how truly incredible and complex the human body is. So, while we marvel at those who heal super fast, we also find ourselves reflecting on the simple, everyday miracle of healing itself. It reminds us that our bodies hold incredible, often unseen powers, always working to make us whole. And even in the quiet moments of rest, our inner strength is diligently at work, a testament to the quiet, powerful resilience that exists within all life. The sound of the aurora's light show. Have you ever looked up at a sky full of dancing lights? The aurora borealis, the northern lights, is a sight many dream of seeing. It shimmers green and pink, a silent, breathtaking ballet high above the earth. But what if those lights weren't so silent? What if, as you watch them swirl, you could actually hear them? For centuries, people living in the far north have told stories of the aurora making sounds. They describe faint crackling, soft popping, or a gentle swishing, like crinkling paper or distant static. Imagine standing under those incredible lights, feeling the cold air, and then a whisper from the sky itself. For a long time, scientists thought these stories were just imagination, maybe the sound of wind in the trees, or even the sound of your own blood rushing in your ears in the quiet, frozen night. After all, the aurora happens high in our atmosphere, more than 60 miles above us. Sound doesn't travel well that far up, especially from something that is essentially light. It just didn't make sense. But here's the thing. Too many people, from different places and times, kept reporting these sounds. Indigenous peoples in the Arctic, ancient sailors, and modern-day explorers all shared similar experiences. It started to become harder to ignore. These were not just isolated tales. It felt like nature was holding a secret, and only a few were close enough to hear it. This is where science meets mystery, where what we think we know gets challenged by real human experience. So, if it's not the light itself making the sound, what could it be? Picture this. Our sun constantly shoots out tiny charged particles. When these particles hit Earth's magnetic shield, they get pulled towards the poles. There, they crash into gases in our atmosphere, making them glow. That's the aurora. Now, imagine those same charged particles. They're like tiny sparks, full of energy. Scientists now think the sounds might not come from the aurora way up high. Instead, they might come from something happening much closer to the ground, caused by the same electrical energy that creates the lights. Think about shuffling your feet on a carpet on a dry day, then touching a doorknob. You might see a tiny spark, and often, you hear a faint crackle or snap. That's static electricity, a sudden release of energy. Something similar, but much more subtle and widespread, might be happening with the aurora. The powerful electrical changes happening high above could create disturbances or electrical fields that reach down closer to us. These fields might then interact with something in the air right around you, like cold air layers or even tiny dust particles. When these little interactions happen very close to the ground, they could create a small, localized sound that only someone standing directly under them would hear. It's not the light making noise, but perhaps the electric echo of the light, playing out very near your ears. And that's why it's still one of those unexplainable science phenomena. Even with these newer ideas, we don't have a perfect answer. The sound is often too faint for microphones to pick up reliably. It's often reported during very strong aurora displays, but not always. It's a whisper from the cosmos, a hint that there's more to reality than what we can always see or easily measure. So, the next time you think about the magnificent aurora, remember its secret song. It reminds us that our world, our universe, is still full of wonders we don't fully understand. It whispers to us that even in the most beautiful and distant phenomena, there might be a subtle, hidden layer waiting to be discovered, a gentle reminder that there's always more to learn, more to experience, and more mysteries to ponder as we drift into sleep. The ocean's deepest, darkest spots. Have you ever wondered what lies at the very bottom of our world's oceans? Imagine a place so deep, so dark, that sunlight has never touched it. A place where the weight of miles of water presses down with unbelievable force. These are the ocean's deepest spots, the parts of our planet that remain mostly a mystery. Think about it. We've sent probes to other planets. We have telescopes that look billions of light years into space. But the very floor of our own oceans, right here on Earth, holds secrets we haven't even begun to fully understand. These deep places are called ocean trenches. They are like giant canyons cut into the seafloor, some stretching for thousands of miles. The most famous one is the Mariana Trench in the Pacific Ocean. Its deepest part, known as the Challenger Deep, goes down nearly 7 miles. To give you an idea of that depth, if you put Mount Everest into the Challenger Deep, its peak would still be more than a mile underwater. It's an astonishing thought, isn't it? The darkness there is absolute. No light from the sun reaches these depths. It's darker than any night you've ever experienced. Darker than a closet with the door shut. Because of this, plants can't grow there, as they need sunlight. But life still finds a way. And that's where things get truly unexplainable. Life in these deep trenches has adapted in ways that seem like something out of a science fiction movie. Many creatures there make their own light, a process called bioluminescence. They glow in the darkness, flashing like tiny living stars. Some have huge eyes to catch any faint glimmer, while others have no eyes at all, relying on other senses to navigate and find food. What's truly strange is that scientists keep finding new species, creatures that look like they belong to another world, thriving in conditions we would find impossible. We still don't fully get how some of these organisms survive the intense pressure, or how their entire ecosystems work without light. Let's talk about that pressure for a moment. At the surface of the ocean, the air around you and the water above you create a certain amount of pressure. But go down to the Challenger Deep, and the pressure is over 1,000 times greater than at the surface. It's like having 50 jumbo jets piled on top of you. Or, if you prefer a different image, imagine putting a full-size car on your thumb. That's the kind of pressure these deep-sea creatures live under every single day. Their bodies are built to handle it, often without air-filled spaces that would collapse. We still don't fully grasp the exact biological mechanisms that allow this. It's a puzzle. And then there are the sounds. The deep ocean is not silent. Hydrophones, which are microphones designed for water, pick up all sorts of noises. Some are from earthquakes or underwater volcanoes, but others are different. Scientists have recorded strange, booming sounds, clicks, and eerie moans that they can't always identify. Are they unknown animals? Strange geological shifts? We don't know for sure. The vastness of these deep, dark places means there's so much we haven't heard, so much we haven't seen. For centuries, people imagined sea monsters and mythical beasts in the ocean's depths. While we haven't found actual dragons, the real creatures we have found are almost as incredible, showing us just how amazing life can be. Before modern technology, these deep places were just stories, rumors of the abyss. Now, we can send robots down, but even with our best tools, it's like peering into a vast, dark room with only a tiny flashlight. We get glimpses, but the full picture remains hidden. Here's the thing. These mysterious parts of the ocean remind us that even on our own planet, there are still huge areas we know very little about. They challenge us to think about how life adapts to the most extreme conditions. They make us wonder about the incredible diversity of Earth, much of which is still waiting to be discovered. It's a quiet reminder that the most profound mysteries aren't always far away in space, but sometimes right here, just beneath the surface of the blue, waiting in the deep, dark quiet. What are cosmic rays really? Have you ever looked up at the night sky and felt a strange wonder, thinking about all the things out there we can't see? Beyond the planets, beyond the furthest stars, something amazing is constantly happening. Our Earth is being showered by invisible particles, tiny bits of matter moving at incredible speeds. These are cosmic rays, and they are one of the universe's deepest, quietest secrets, happening all around us, all the time. So, what exactly are they? Here's the thing. Cosmic rays are not really rays like light rays. They are more like tiny, super-fast bullets. Most of them are just single protons, which are the centers of hydrogen atoms. Some are the nuclei of other atoms, like helium or even heavier elements, stripped of their electrons. Imagine the very basic building blocks of matter, but with an almost unbelievable amount of energy. They travel through space at nearly the speed of light. This means they are almost as fast as anything can possibly go. Where do these super-fast particles come from? Well, that's part of the mystery. We know many of them are born in violent cosmic events. Think about huge stars exploding in what's called a supernova, or maybe from the powerful magnetic fields around black holes, or even from active galaxies far, far away. These explosions and powerful forces give these tiny particles their incredible speed, flinging them across the universe for millions of years, until some of them reach our little blue planet. People didn't always know about cosmic rays. For a long time, scientists thought all the radiation they detected came from Earth itself. But a brave scientist named Victor Hess, about 100 years ago, decided to test this idea. He took balloons carrying special instruments high up into the atmosphere. What he found was truly surprising. The higher he went, the more radiation his instruments detected. This meant the radiation wasn't coming from Earth. It had to be coming from space, from the cosmos. And that's why he called them cosmic rays. His discovery opened up a whole new way to think about our universe. To imagine their power, think about a tiny grain of sand. If you just held it in your hand, it's nothing, right? But what if that grain of sand could fly almost as fast as light? If it hit you, it would have the force of a bowling ball. Cosmic rays are like those super fast, super tiny particles. They constantly hit our atmosphere. Most of them crash into atoms in the air, creating showers of other smaller, less energetic particles. Some of these new particles can even reach the ground, passing through buildings, through us, through everything. It's like an invisible rain, a silent bombardment that has been happening for billions of years. So, as you lie here, listening, know that even now, invisible particles that have traveled across unimaginable distances from distant stars and galaxies are passing through you. They carry within them the echoes of cosmic explosions and the deep energy of the universe. It's a quiet, constant reminder that we are truly connected to the vastness of space, bathed in its unseen energy. It makes you feel small, yes, but also deeply part of something so much grander and more ancient than we can fully grasp. It's a gentle, ever-present whisper from the cosmos, a profound secret unfolding in the quiet of the night. The trick our eyes play on us. Have you ever looked at something and been absolutely sure of what you saw, only to find out later that you were completely wrong? Maybe you saw a face in a cloud, or a shimmering puddle on a hot road that disappeared as you got closer. What if I told you that sometimes the world you perceive isn't exactly the world that is there? Our eyes, those amazing organs that gather light and color, are only the first step. The real magic, or maybe the real trick, happens inside your brain. Here's the thing. Your eyes don't just take pictures like a camera. They gather raw information, light, shapes, colors. But then, your brain steps in. It's like a powerful detective, constantly trying to make sense of all that information. It uses everything it knows, every experience you've ever had, every memory, to build a picture of reality. Most of the time, this system works incredibly well. It helps us navigate the world, avoid dangers, and recognize friends. But sometimes, this very clever system can get a little confused. Our brains, in their effort to help us, can play tricks on us. This idea that what we see isn't always the absolute truth isn't new. For centuries, thinkers and scientists have wondered about it. Ancient philosophers questioned if our senses truly showed us the world as it is, or just our brain's version of it. They understood that perception, the way we experience the world, is not always the same as reality. It's a deep concept, suggesting that maybe everyone lives in their own slightly different world, colored by their own unique brain. Think about the moon when it's low on the horizon, just peeking above the trees or buildings. Doesn't it look enormous? Like a giant, glowing orb that's much bigger than when it's high up in the sky. But here's the quiet secret. The moon itself doesn't actually change size. It's the same distance, the same physical size, whether it's low in the sky or high above. This is a classic example of an optical illusion, often called the moon illusion. Your brain is playing a trick on you. Why does it do this? When the moon is low, your brain sees it next to familiar things: trees, houses, mountains. Your brain uses these familiar objects as reference points. It expects distant objects that appear near other objects to be smaller. But the moon isn't smaller. So, your brain corrects this by making the moon seem bigger to fit its expectations. When the moon is high in a vast, empty sky, there's nothing to compare it to. Your brain doesn't have those close-up reference points, so it perceives the moon at its actual perceived size, which seems smaller. It's your brain trying to make sense of the world based on its usual rules. And in this case, the rules don't quite fit. It's not just the moon. Have you ever seen those images where you can see two different things, like an old woman or a young woman, depending on how your brain interprets the line? Or the famous Mueller-Lyer illusion, where two lines of the exact same length look different because of the arrows at their ends. These aren't errors in your eyes. Your eyes see the lines as they are. The trick is in your brain, constantly processing, interpreting, and sometimes misinterpreting the information it receives. So, what does this tell us? It reminds us of the profound mystery and complexity of our own minds. Our brains are not just passive receivers of information, they are active creators of our reality. They are always working, always making guesses, always building the world we experience. This understanding can be a gentle reminder to always be a little curious about what we see, to question, not with doubt, but with wonder, how our amazing minds shape the world around us. It teaches us that perception is a deeply personal journey, a unique construction made by the incredible brain we each carry. Is there a parallel universe nearby? Have you ever wondered, what if? What if you had picked a different outfit this morning? What if you had turned left instead of right on your walk home? Sometimes, these small what-ifs grow into really big questions. One of the biggest questions is, what if there's another version of you out there, living a different life because of a different choice? The idea of a parallel universe is like imagining another Earth, or even many Earths, existing at the same time as ours. In one, maybe dinosaurs never went extinct. In another, maybe you have a pet dragon. It's about realities that run alongside our own, but where things might have played out differently. Think of it like this. Every single decision, every tiny moment, might not just happen one way. It might happen in countless ways, each creating its own separate reality. For a long time, the thought of parallel universes was just something you'd read about in comic books or see in movies. It felt like pure science fiction, a fun idea, but not something real. But then, some of the smartest scientists started looking at the very smallest things in our universe, the tiny building blocks of everything around us, smaller than even atoms. And what they saw made them wonder. These tiny particles, when studied very closely, sometimes act in ways that are truly strange and hard to explain. It's almost as if they can be in many different places or states at the same time, until we actually look at them. This strange behavior got scientists thinking. What if everything, not just tiny particles, exists in many different ways until we observe our own reality? Imagine you're playing a video game where your choices change the story. If you pick path A, the game goes one way. If you pick path B, it goes another. A parallel universe theory suggests that maybe both paths actually happen. Somewhere, in another reality, the you who chose path B is living out that story. Every single choice, every tiny decision you've ever made could, in theory, create a new branch, a new reality, where you chose differently. It's not about magic, but about what might be possible if the rules of the super tiny world also apply to our big universe. So, if there are endless yous living endless lives, what does that mean for us? Does it make our own life less important? Or does it make this moment, this reality, even more special and unique? It's not about wishing we were in another reality. It's about understanding that our universe, the one we live in right now, might be just one tiny dot in an unimaginably vast ocean of existence. It makes you look at a simple choice, like which shoe to tie first. and realize that even that tiny moment could have an infinite number of echoes. It's a humbling thought, a deep breath in the quiet night, reminding us of the endless mystery that surrounds us, even in the smallest things. Our reality is here, now, and perhaps it is one of countless possibilities, making it all the more beautiful and profound. The strange behavior of water in space. Have you ever stopped to think about water? It's everywhere around us. It fills our oceans, flows in rivers, comes out of our taps. We drink it, we wash with it, we see it every day, and it always seems to act the same way. It flows, it splashes, it settles flat in a glass. But what if I told you that in space, water acts like a completely different substance? What if the very nature of something so common here on Earth becomes a strange, beautiful mystery just a few hundred miles above us? When we think of water, we usually imagine it reacting to gravity. Gravity is the invisible force that pulls everything down. It makes apples fall from trees and keeps our feet on the ground. For water, gravity pulls all its molecules downward, making it spread out or pool at the bottom of containers. It's why a waterfall falls and why a spilled drink makes a flat puddle on the floor. It's just how water behaves, right? But in space, inside a spacecraft like the International Space Station, there's a special condition called microgravity. It's not totally zero gravity, but it's very close. It means the pull of Earth's gravity is incredibly weak inside the station. And when gravity's strong hand lets go, water truly shows its wild side. Instead of flowing or spreading, water forms perfect, shimmering spheres. Imagine a giant, floating blob of water, like a supersized raindrop, drifting through the air. That's what water does in space. Why does it do this? It all comes down to something called cohesion and surface tension. Cohesion is like water molecules, loving to stick to each other. They're drawn together, almost like tiny magnets. On Earth, gravity is stronger than this stickiness, so it pulls the water down. But in space, with gravity barely there, cohesion takes over. All those little water molecules pull inward, trying to get as close as possible to each other. The most efficient shape they can form when pulling inward equally from all sides is a sphere, a perfect ball. Then there's surface tension. Think of it like a thin, flexible skin on the outside of the water blob. It's this skin that holds the sphere together, preventing it from breaking apart easily. You can see a tiny bit of surface tension here on Earth if you look closely at a droplet of water on a leaf, or how water beads up on a freshly waxed car. In space, that skin becomes much more noticeable, holding large amounts of water in a stable, spherical shape. Astronauts can even push these water blobs around, or insert a straw into them to drink, without the water breaking apart. It's truly amazing to watch. For centuries, people thought of water as one of the fundamental elements, always behaving the same way. Ancient philosophers like the Greeks believed water was one of the building blocks of the universe, with its own fixed properties. They would have been utterly astonished to see water floating freely, forming perfect spheres, not bound by any container. It shows us how much our understanding of the universe relies on our perspective, on where we are. What seems like a fundamental rule on Earth can be completely different somewhere else. It's a quiet lesson, really. This strange dance of water in microgravity reminds us that what we take for granted, what seems ordinary and unchanging in our daily lives, might hold deeper secrets. It whispers to us about the hidden forces at play, forces we don't always notice until something shifts, until we step outside our familiar world. It's a gentle reminder to stay curious, to look past the obvious, and to understand that even the most common things can reveal extraordinary truths about the universe and its quiet, unexplainable wonders. Why does our hair get statusy? Have you ever pulled off a cozy hat on a cold day and watched your hair suddenly leap into the air, standing up in all directions? Or maybe you've rubbed a balloon on your sweater and then tried to stick it to the wall, only for it to cling there like magic. That strange, sometimes funny, sometimes shocking feeling is static electricity, and it's a perfectly normal, fascinating part of our world. So, here's the thing about why your hair decides to have a mind of its own. Everything around us, and I mean absolutely everything, is made of tiny, tiny pieces called atoms. Inside these atoms are even tinier particles. Some of these particles, called electrons, have a negative electric charge. Other particles, called protons, have a positive electric charge. Normally, most things have an equal number of electrons and protons, so their positive and negative charges balance out. This means they are electrically neutral or balanced. But when you rub certain materials together, like your hair and a wool hat, or a plastic comb through dry strands, these tiny electrons can actually jump from one object to the other. Imagine it like a game of musical chairs, but for electrons. When your hair rubs against that hat, electrons might leave the hat and stick to your hair. Now, your hair has too many negative electrons, making it negatively charged. The hat, having lost electrons, becomes positively charged. And here's why that matters. Objects that have the same type of charge, like all those strands of your hair, now each carrying extra negative electrons, they don't like to be near each other. They push each other away. It's like trying to push the positive ends of two magnets together. They resist. So, each hair strand tries to get as far away from its neighbors as possible, making your hair stand out and sometimes even float. It's even more noticeable in dry air, especially in winter. Why? Because when there's more moisture in the air, the water molecules can help move those extra charges away or ground them, letting your hair become neutral again. But in dry air, there's nothing to help those charges escape, so they build up. This is also why you might get a little shock when you touch a doorknob after shuffling your feet on a carpet. You've picked up extra electrons, and when you touch something metal, they suddenly jump off you, trying to find balance. People have noticed these strange forces for a very long time. Thousands of years ago, the ancient Greeks found that if they rubbed a piece of amber, which is fossilized tree sap, it could pick up light things like feathers. They called amber electron, which is where we get the word electricity from. They didn't understand the electrons or charges, but they saw the mysterious effect. It was just one of those weird, unexplained things that hinted at unseen powers in the world. So, the next time your hair stands on end, or you feel that tiny jolt, remember you're experiencing a very basic but powerful force of nature. It's a quiet dance of invisible particles, always in motion, always trying to find balance. It's a reminder that even the simplest, most everyday things, like your hair after pulling off a sweater, hold clues to the deeper, hidden rules of the universe. It's all part of the vast, silent energy that hums through everything around us, even when we can't see it. The oldest rocks that tell no tales imagine. For a moment, a time so far back it's almost impossible to picture. We're talking before dinosaurs roamed, before the first tiny plants grew, even before the mountains we know today ever pushed up from the ground. What do you think our Earth looked like then? What stories could it tell if it could speak? Scientists are like detectives, trying to piece together the planet's past. They look at rocks, because rocks are like history books, holding clues about what happened millions, even billions, of years ago. Here's the thing though. When we look for the very first pages of Earth's story, for the oldest, original rocks that formed when our planet was just a baby, those pages are mostly missing. This is one of science's biggest mysteries. The oldest rocks that tell no tales. So, what does that mean? Our Earth formed about 4.54 billion years ago. Think of that number. For the first 500 million years or so, it was a wild place. It was incredibly hot, with volcanoes erupting everywhere, and the surface constantly melting and changing. Giant asteroids kept crashing into it. This early period is often called the Hadean Eon, which sounds like hell-like, because it was so fiery and chaotic. During this time, the very first solid rocks would have formed as the super-hot molten material cooled. These would be the true firstborn rocks of our planet. But here's the problem. Almost none of them exist today in their original form. It's like having a family photo album that starts with your grandparents, but all the pictures of your great-grandparents and even earlier ancestors are missing. You know they existed, but the direct evidence, the specific photos, are just gone. Scientists have found tiny, tiny mineral grains, like specks of dust, called zircons. Some of these zircons are incredibly old, around 4.4 billion years old. They are the oldest pieces of Earth's crust we've ever found. Think of them as individual letters from a huge, missing book. They prove that something was solid that long ago, that a crust was forming. But they don't give us the full story. They don't tell us what the entire landscape looked like, what the atmosphere was like, or how the very first oceans formed. The tale of that early Earth, written in its first rocks, has largely been erased. Why are these stories lost? Imagine baking a cake. If you kept melting it down and baking it again and again, and also kept throwing different ingredients into it, the original cake from the very first recipe would be impossible to find or even taste. Our Earth was like that. All the volcanic activity, the constant churning of the surface, the impacts from space rocks, and the movement of the continents over billions of years have recycled and remelted almost all of those early rocks. They've been pushed deep down, melted, and reformed into new rocks. The original memory of those first rocks is gone. This mystery reminds us that even with all our incredible tools and knowledge, some parts of our own planet's history remain hidden, swallowed by time and the Earth's own powerful processes. It's a humbling thought, isn't it? To know that the very beginnings of our world are shrouded in a silence that even the oldest rocks cannot break. It makes us wonder about all the other secrets the universe holds, sleeping quietly, waiting to be discovered, or perhaps never to be known. When space sounds like a ghost, have you ever thought about what space sounds like? Most of us picture it as completely silent, a quiet, empty place where no sound can travel. And in a way, that's true. Here's why. Sound as we know it, like your voice, or the music you hear, travels through air, water, or solid objects. It needs something to move through, like ripples in a pond. But space is mostly a vacuum. That means it's almost totally empty, with very few particles for sound waves to bounce off. So, if you were to shout in space, no one would hear you, because there's nothing for your shout to travel through. But here's the thing that makes space sound like a ghost. Even though sound waves can't travel there, other kinds of waves can. These are called electromagnetic waves. Think of them like invisible waves of energy. Light is an electromagnetic wave. Radio signals are electromagnetic waves. Even the signals that carry Wi-Fi to your phone are electromagnetic waves. They don't need air or water to move. They can zoom right through the emptiness of space. Now, how does this connect to sounds? Well, planets, stars, and even cosmic dust clouds all give off these electromagnetic waves. They create a kind of unseen buzz or hum throughout the universe. Our ears can't pick up these waves directly. We need special tools, like the instruments on spacecraft and satellites. These tools are designed to listen to these electromagnetic waves. They capture the signals, and then scientists can take those signals and turn them into something we can hear. They translate the waves into audio frequencies, which are the sounds our ears can understand. So, when we talk about sounds from space, we're not hearing the actual roar of a planet or the whisper of a star like you'd hear a car drive by. Instead, we're hearing these electromagnetic signals translated for our human ears. And what do they sound like? Sometimes they're strange, eerie whistles. Other times, they are deep, low hums, like a giant machine running far away. Some even sound like strange, ghostly moans or crackling static. It's truly unlike anything you hear on Earth. Imagine turning on an old radio, but instead of music, you hear the deep, mysterious pulse of Jupiter, or the ghostly echo of a distant nebula. That's what it can be like. For a long time, people just thought space was silent, a vast, quiet nothingness. It wasn't until we sent probes out into the solar system that we started picking up these hidden energies. It's a bit like discovering a whole new language that the universe has been speaking all along, but we just didn't have the right ears to hear it. It makes you wonder, what else is out there, always happening, but just beyond what our normal senses can pick up? It shows us that even what seems empty is full of activity, just a different kind of activity. Think about a time you've been in a really quiet room, maybe late at night. You might start to notice faint sounds you wouldn't normally hear. The hum of the refrigerator, the distant rumble of a car, or maybe even the sound of your own blood rushing in your ears. These are tiny background noises that are always there, but usually drowned out by louder sounds. The sounds of space are kind of like that. but on a cosmic scale. They are the universe's background hum, the faint whispers and thrums of energy that are always present, even in the deepest, darkest corners of space. Our spacecraft act like giant, sensitive ears, picking up these subtle vibrations and letting us listen in. And that's why it's so mysterious. We can hear these things, but we don't always fully understand why they sound the way they do, or what exactly causes every single one of those strange whistles and hums. They are the raw, untamed voice of the cosmos, echoing with energies we are only just beginning to comprehend. It tells us that the universe is never truly empty, never truly silent. Even in its vast, cold emptiness, there is always energy, always movement, always a kind of cosmic music playing, a deep, unseen song that reminds us how much there is still to learn and how much wonder exists beyond our everyday world. It is a soft, constant reminder that even silence can be full of secrets, waiting for us to just listen a little closer. The mystery of why we yawn. Have you ever noticed how sometimes a yawn just takes over? That big stretch, that deep breath, it feels so simple, so natural. A quiet moment where your mouth stretches wide and your eyes might even water. But what's really going on when your body takes that involuntary gaping breath? What deep, unseen purpose does it serve in the complex orchestra of our human existence? For a very long time, people thought yawning was all about needing more oxygen. The idea was that if your body was low on oxygen, it would make you yawn to suck in a big gulp of air. It seemed logical, like your body's simple way of saying, "Hey, breathe deeper, you're running low." But scientists have actually looked into this theory very closely. They've done experiments where people breathe air with different amounts of oxygen. And here's the thing. People yawn just as much in places with lots of oxygen as they do in places with less. So, while it was a common belief for ages, that particular theory doesn't quite fit the evidence we have now. A newer idea, and one that many scientists are leaning towards today, suggests something more subtle and fascinating. This theory proposes that yawning helps to cool down your brain. Think about it. When you take a deep, wide breath, especially through your mouth, a rush of cool air enters your airways. This cool air might help lower the temperature of the blood flowing into your brain, almost like an internal air conditioner. This makes a lot of sense, because we tend to yawn more when we're tired or bored, and the temperature of our brain can actually rise a little in those moments. It's as if your brain is saying, "Okay, time for a little cool down to stay sharp." And when your brain is at its best, most optimal temperature, it works better, helping you stay alert and focused. So, a yawn might be a quick, clever way your body tries to reboot your brain, making it sharper for a moment, keeping you engaged when you might otherwise drift off. Throughout human history, this common act has puzzled thinkers and everyday people alike. Ancient Greeks and Romans, for instance, often saw yawning as more than just a physical action. They sometimes believed it was a way for bad air or even evil spirits to leave the body, a method of cleansing oneself of negative energy. Some cultures linked it to spiritual messages, prophetic visions, or signs of inner struggles. It was a mysterious event, often seen as a doorway between the inner self and the outer world. We've certainly come a long way from those ancient mystical ideas, using modern science to look deeper into the biological reasons. But even with all our knowledge, there's still a certain simple wonder to something so common, yet so profoundly puzzling. Here's another curious part of the mystery. Yawning is often incredibly contagious. Have you ever noticed this? You see someone yawn, and almost instantly, you feel the urge to do it too. It's like a quiet, unspoken chain reaction. Imagine you're sitting in class, maybe feeling a little sleepy, and the person a few desks away lets out a big, audible yawn. Before you know it, that feeling of a yawn might start building inside you, and you might find yourself stretching your jaw wide too. This contagious yawning is one of the most fascinating aspects, because it suggests that yawning isn't just about what's happening inside your body alone. It might also be linked to empathy, to our ability to subtly feel what others are feeling, or to some deeper, unspoken way we connect with each other. It's a shared moment, a silent signal that hints at the intricate social bonds that tie us together, even when we don't fully understand the why behind it. So, While we have some very strong ideas about why we yawn, the exact, complete reason remains a bit of a whisper in the wind, a gentle secret held by our biology. Is it purely for brain cooling? Is it a way to stretch and wake up the muscles in our face and jaw before we're fully awake or alert? Is it truly a deep, ancient form of communication? A silent, empathetic message shared between us? A way for our bodies to echo what we perceive in others? Perhaps it's a beautiful combination of all these things, working together in ways we are still trying to understand and unravel. It reminds us that even the simplest, most everyday actions of our bodies hold profound secrets. Our human bodies are incredible, complex machines, constantly performing countless actions we rarely think about, often for reasons we haven't fully figured out yet. A yawn, that quiet, open-mouthed moment, is a gentle reminder of the vast, unexplored territory within ourselves and the mysterious, interconnected world around us. It's a tiny mystery, happening right under our noses, inviting us to stay curious, to keep asking why, and to appreciate the subtle, deep wonders of being alive. What makes magnets stick? Have you ever held two magnets in your hands, felt them pull towards each other, or push away with an invisible force? It's a quiet mystery, isn't it? Something unseen, yet undeniably real, guides their every move. What is this hidden power that makes a tiny fridge magnet cling to steel, or a compass needle always point north? It feels like magic, but it's a deep part of the universe we are only beginning to truly understand. For thousands of years, people have noticed this strange effect. Ancient Greeks found a certain type of rock called lodestone that could attract iron. They didn't know why, but they saw its power. It was like the rocks had a secret handshake with some metals. Imagine their wonder, seeing something move without being touched, drawn by an invisible pull. They might have thought it was a spirit or a gift from the gods. This wonder, this curiosity about the unseen, is where science truly begins. Here's the thing. Everything around us, including you and me, is made of tiny, tiny particles called atoms. Inside these atoms are even smaller bits called electrons. These electrons are always moving, spinning, and this movement creates a tiny magnetic field. Think of each electron as a microscopic spinning top, creating its own little invisible force field. In most materials, these electron magnets are all jumbled up, pointing in every direction. So, their tiny forces cancel each other out. It's like a room full of people shouting in different languages you can't understand anything. But in certain materials, like iron, nickel, and cobalt, and in the magnets we use every day, something different happens. The tiny magnetic fields of many electrons line up. They point in the same direction, like an army marching in unison, or a choir singing the same note. When enough of these tiny fields line up, they create a stronger, overall magnetic field that extends beyond the material itself. This is what we call a magnet. So, when you bring two magnets together, their invisible fields interact. If opposite ends meet like the north of one and the south of another, they pull each other. It's a connection, a powerful attraction. If the same ends meet north to north or south to south, they push apart, resisting each other. It's an unseen push and pull, governed by these aligned microscopic forces. Think about how we sometimes feel drawn to certain people, or pushed away by others. It's not exactly the same, but it's a way to imagine invisible forces. Just as a strong, shared idea can pull a group of friends together, the aligned ideas of countless tiny electrons create the pull of a magnet. We use magnets in so many ways. In speakers to make sound, in computers to store information, in medical machines to see inside the body. They are a quiet, fundamental part of our modern world. Yet, even with all our understanding, the deeper why of magnetism remains a profound question. We know how electrons behave and what their alignment does. But why do these fundamental particles have this property? Why do they create these fields? These are the deeper mysteries, the quiet wonders that echo in the space between our knowing and the endless unknown. It reminds us that even in the most common things, like a magnet on a fridge, there are layers of wonder and a silence of unsolved questions waiting for us to ponder. The universe holds so many secrets, resting just beneath the surface of what we can see and touch. The unexplained blue jets in the sky. Have you ever looked up at the sky during a big thunderstorm? You see the lightning flash downwards, right? Sometimes it flashes between clouds, or from a cloud to the ground. But what if I told you there are strange, quick bursts of light that shoot upwards from the very top of these storms, straight towards space? Here's the thing. They're called blue jets, and for a long time, we didn't even know they existed. Imagine an enormous, powerful thunderstorm stretching miles high into the sky. At the very top, where the storm meets the calm, cold upper atmosphere, sometimes a blue jet will fire off. It's like a giant, super-fast spark, but instead of going down, it goes up. These aren't regular lightning. They don't zigzag like the lightning bolts, you know. Instead, they look more like a cone or a narrow column of blue light, shooting up at incredible speeds. They can reach as high as 30 miles into the atmosphere, which is way, way above where airplanes usually fly. And they happen incredibly fast, lasting only a fraction of a second. Blink, and you'll miss them. So, what are they, exactly? Well, scientists are still trying to figure out all the details, but here's what we understand so far. Regular lightning happens when there's a huge difference in electrical charge inside a cloud, or between a cloud and the ground. Think of it like rubbing your feet on a carpet and then touching a metal doorknob. That little spark is electricity jumping from you to the doorknob because of a charge difference. Now, imagine that on a massive scale, with billions of tiny ice particles and water droplets rubbing against each other inside a thunderstorm. They build up enormous electrical charges. For blue jets, it's believed that a different kind of electrical unbalance happens at the top of the storm. Instead of charges needing to connect to the ground, they're trying to balance themselves out with the calm upper layers of the atmosphere. So, the electricity finds a path upwards, creating this amazing blue glow. The blue color probably comes from the way the light interacts with the nitrogen gas in our atmosphere. It's like when neon signs glow different colors because of the gases inside them. For a long time, blue jets were just stories told by pilots or sailors who thought they'd seen something strange. People didn't believe them much. It wasn't until the early 1990s that scientists finally caught clear images of these events from space and from planes. Imagine being a scientist, studying something you've only heard whispers about, and then finally getting proof. It was a huge moment, showing us that even the sky directly above us holds secrets we haven't fully explored. Studying them is hard. They're rare, they're fast, and they only happen over powerful storms, often out over oceans where there aren't many people watching. Scientists use special cameras on planes or even satellites to try and capture them. They want to understand why they happen, how often, and what role they play in Earth's electrical system. It's a reminder that even in our modern world, with all our technology, the planet still has mysteries unfolding above our heads every day. And that's why it matters. It reminds us that our world is far more complex and wonderful than we often realize. Even the air we breathe, the clouds we see, hold hidden light shows and scientific puzzles. These blue jets, shooting silently into the vastness, are a gentle whisper from the unknown, inviting us to keep looking up, to keep wondering, and to remember that there's always more to discover, even in the most familiar places. The sky is full of quiet wonders, waiting for us to notice them. How butterflies know where to go. How do butterflies know where to go? Think about it. A tiny creature, no bigger than your hand, can fly thousands of miles, not just once, but year after year. And not just the same butterfly, but its great-great-grandchildren. How do they find the exact same trees, in the exact same forest, sometimes even the exact same branches, when they've never been there before? It's one of nature's biggest mysteries. Take the monarch butterfly. Every fall, millions of them leave Canada and the US. They fly all the way to Mexico or parts of California. This journey is incredibly long and dangerous. But here's the amazing part. The butterflies that start the journey are not the ones that finish it. Monarchs have short lives. So it takes several generations, maybe 3 or 4, for the journey to be completed. The butterflies that arrive in Mexico for the winter are the great-great-grandchildren of the ones who left. And somehow, they know the way. Scientists have studied this for a long time. They've found some clues. For example, monarchs use the sun as a compass. They can adjust for the time of day, just like if you were using a map and compass. They also seem to use the Earth's magnetic field, like a built-in GPS. But here's the thing. These explanations don't fully tell us how they pinpoint a specific forest or how the knowledge is passed down. It's not like their parents or grandparents could tell them stories about the trip. This guidance seems to be born within them, a deep, silent knowledge. For centuries, people have watched these migrations and wondered. It makes us think about what else we don't understand about the natural world. We have so much technology now. Satellites, computers, maps that can show us every street on Earth. But we still can't explain this deep wisdom in a tiny insect. It's a bit like trying to understand a secret language that only butterflies speak. Imagine you're playing a new video game. It's a huge open world, and you have to find a hidden treasure. You've never played this game before, but somehow, deep down, you just know where to go. You follow a path you've never seen, make turns you've never practiced, and arrive exactly at the treasure. That's kind of what the monarch butterfly does. But for real, they aren't following maps. They're following an instinct, a feeling, a knowledge embedded in their very being. It's like a program written into their very existence, but it's so complex, we can't quite read it yet. This mystery reminds us how much wonder is still out there. It shows us that even the smallest creatures hold incredible secrets. When you see a butterfly gently fluttering by, remember that it might carry an ancient knowledge, a kind of internal guidance system that no human invention can truly match or explain. It flies on, guided by something we can't see, can't touch, and can barely even imagine. And that's okay. Sometimes, the most beautiful things in the world are the ones we don't fully understand. They invite us to look closer, to be curious, and to simply be amazed. It's a quiet thought, but a powerful one. The world is full of these small miracles, reminding us that there are forces and intelligences far beyond our grasp, gently guiding life, even the smallest butterfly, exactly where it needs to go. This deep knowing, this hidden wisdom in nature, truly is something to fall asleep thinking about. The odd way crystals form. Have you ever looked really closely at something simple, like a grain of salt, or maybe a tiny ice cube? You might notice they have these sharp, straight edges and flat surfaces. They look like perfect little geometric shapes. We call these crystals. And here's the thing. How they form is one of the most amazing and kind of mysterious things in science. Think about it like this. Imagine you have a big pile of Lego bricks. You dump them out of the box. Now, imagine those Lego bricks just started clicking together, all on their own, to build a perfect, complex castle, without anyone telling them how. No instructions, no human hands, just them arranging themselves into an exact, repeating pattern. That's a bit like what happens when crystals form. What exactly is a crystal? It's when atoms or molecules arrange themselves in a very specific, repeating pattern. They line up like tiny soldiers in perfect rows, creating a structure that extends in all directions. Salt, sugar, snowflakes, diamonds, quartz, these are all crystals. They don't just clump together randomly. They build these incredibly precise, beautiful shapes. For a long, long time, people saw crystals and thought they were magical. How else could something so perfect appear from plain water or a messy solution? Ancient cultures often believed crystals held special powers because their perfect forms seemed to come from nowhere, like gifts from the gods or spirits. They looked like nature's attempt at perfection. Philosophers and thinkers would look at these natural formations and wonder, what kind of hidden rules or blueprint guides the universe to create such order and beauty? It's like the universe has a secret language, and crystals are some of its most eloquent words. The amazing part, the unexplainable part, isn't just that they form, but how these tiny individual atoms or molecules, bouncing around in a liquid or gas, suddenly know exactly where to go. They find their spot. They connect. And then, the next one comes along and finds its spot, perfectly fitting into the growing structure. It's not like there's a giant magnet pulling them into place, or a tiny architect directing traffic. The atoms just know. Take water turning into ice, for example. When water cools down enough, its molecules slow down. As they slow, they start to link up. But instead of just forming a random blob of ice, they form intricate six-sided snowflakes or hexagonal ice crystals. Each snowflake is unique, yet every single one follows that strict six-sided rule. How does each water molecule understand the blueprint for a perfect hexagon? How do countless molecules coordinate their movements to build something so complex and symmetrical? Scientists have theories, of course. They talk about energy states, about how atoms naturally arrange themselves in the most stable, lowest energy way. It's like a ball rolling down a hill. It naturally finds the lowest spot. Atoms are doing something similar, finding their happy place in a perfect crystal lattice. But even with all the scientific understanding, there's still a deep mystery. How does this happy place translate into such precise, large-scale order from something as simple as atoms bumping into each other? How does chaos transform into such perfect, predictable harmony every single time? It makes you pause and think. The world is full of these small, quiet miracles. Things we see every day, like a grain of sugar, hold a secret about the universe's incredible ability to create order from disorder. It reminds us that even in the most basic materials, there are profound principles at work, principles we are still trying to fully grasp. And sometimes, the most beautiful things are the ones we can't quite explain, the ones that make us simply wonder at the quiet brilliance of nature itself. The simple, perfect geometry of a crystal whispers of a deep, hidden intelligence, or a fundamental law in the very fabric of existence, patiently waiting for us to notice and appreciate its quiet, precise dance. Why some lakes turn red? Imagine looking out at a lake, expecting to see calm blue or misty green water reflecting the sky. But what if, instead, you saw a vast expanse of bright, deep red? It might feel like something out of a dream, or perhaps a strange, unsettling sign. How could a lake, a body of water, possibly turn such a striking, unnatural color? Here's the thing. These blood lakes aren't a sign of magic or some terrible event, but rather a fascinating display of life thriving in unusual places. The deep red color usually comes from incredibly tiny living things that call these lakes home. We're talking about microbes, specifically certain types of bacteria and algae. These are organisms so small you can only see them with a powerful microscope. But when billions of them gather together, they can change the color of an entire lake. Think about the grass in a field. It's green because of chlorophyll, a special pigment that helps plants make their food from sunlight. Well, these tiny lake dwellers also have pigments, but instead of green, some have red or orange ones. They use these pigments for different purposes, like protecting themselves from harsh sunlight or helping them get energy. So, why do they turn red in some lakes and not others? It often has to do with the conditions in the water. These red pigmented microbes love extreme environments. They thrive in water that is incredibly salty, sometimes even saltier than the ocean. Picture a spoonful of salt dissolving in a glass of water. Now imagine that water having 10, 20, or even 30 times that much salt. Most living things can't survive in such conditions, but these specialized bacteria and algae can. They are what we call halophiles, which literally means salt lovers. Besides extreme saltiness, these lakes often have other specific conditions. They might be very warm, soaking up a lot of sunlight, and sometimes they have low oxygen levels. These are all perfect conditions for certain types of red bacteria to flourish, making the water look like a giant bowl of cranberry juice. It's kind of like how some plants only grow well in a sunny spot, and others prefer shade. These microbes are just really particular about their habitat. A relatable example might be if you've ever seen pond scum turn bright green on a hot day. That's a bloom of green algae. The red lakes are just a different kind of bloom, with different organisms and different colors. It's a natural phenomenon, not unlike how a sunset paints the sky with reds and oranges due to how light scatters through the atmosphere. It's all about the tiny things we can't see, making a huge impact on what we can. For a long time, people didn't understand why these lakes turned red. Imagine being an ancient traveler and stumbling upon a lake that looked like blood. It must have been truly baffling, maybe even terrifying. People might have thought it was a curse, a miracle, or a sign from the gods. Without scientific tools, it was an unexplainable mystery. But over time, as science grew, we learned to look closer, to ask questions, and to find the tiny, often beautiful reasons behind the world's most striking natural events. These red lakes remind us that even in the harshest environments, life finds a way to exist, and not just exist, but to flourish and create something visually stunning. They teach us that what seems strange or unsettling at first glance often has a logical, even elegant explanation. It's a quiet testament to the incredible adaptability of life on Earth, and a reminder that there's always more to discover. Even in something as common as a lake, the world holds wonders in its depths, waiting for curious minds to understand them. The feeling of déjà vu explained. Have you ever walked into a new place, met someone new, or heard a song for the very first time, yet a strange shiver goes down your spine, because it feels like you've experienced this exact moment before? Not just similar, but exactly the same. That unsettling, almost magical sensation is called déjà vu. It's a French phrase, and it simply means already seen. It's a trick our mind plays on us, making the present feel like a memory. But what's really happening when this odd feeling washes over you? For centuries, people have wondered about déjà vu. Some thought it might be a memory from a past life. Others believed it was a glimpse into the future, or a moment where our consciousness connects to something bigger. But scientists and thinkers, especially in more recent times, have started looking at it differently. They suggest it's not about magic or time travel, but about the amazing, intricate ways our brains work. Here's one of the main ideas. Our brains are always taking in information through our senses. What we see, hear, smell, touch, and even taste. It then sorts and stores all this information. Think of your brain like a giant, super-fast computer that's always processing. Sometimes, this computer might have a tiny, momentary glitch. Imagine you're watching a video online. Sometimes, the video might stutter for a split second, then catch up. The sound might play just before the picture. Your brain does something a bit like that with memories. When you experience something new, your brain usually takes it all in at once. Sights, sounds, smells, feelings. It then stores this new information as a new memory. But sometimes, maybe just for a tiny fraction of a second, the different parts of this new information arrive at your brain's memory department at slightly different times. For example, your eyes might see something just a split second before your brain fully registers what it is. In that moment, the brain quickly processes the sight. Then, when the rest of the information, the sound, the feeling, catches up, your brain already has a very fresh, incomplete memory of it. So, it feels like you're experiencing it again, even though it's still the same moment. It's like your brain is accidentally playing back a recording that just happened. Another idea is that déjà vu might happen when there's a quick, partial memory recall. Imagine you're walking into a room you've never been in before, but maybe the arrangement of the furniture, or the way the light comes through the window, is very similar to a room you saw once in a movie, or maybe even in a dream. Your brain quickly finds that old, similar memory, even if you don't fully remember it consciously. Then, as you take in the new room, your brain tries to match it to that partial old memory, and for a fleeting moment, it feels like you've been there before. It's a quick connection your brain makes, often without you even realizing why. So, this strange feeling isn't a peek into the future, or a forgotten past life, but rather a gentle reminder of how wonderfully complex our own minds are. It's our brain working at lightning speed, sometimes so fast that its own processes overlap, creating a brief, fleeting illusion. It's a quiet mystery inside each of us, showing us that even the most common human experiences can hold a touch of the unexplainable, reminding us to wonder about the silent inner workings of our own incredible minds. It's a moment of wonder, a small glitch in the amazing machinery of thought, making us pause and consider the deep, strange world within. What if the universe is a hologram? Have you ever thought about how real things really are? We see the world, we touch it, we live in it. But what if it's all just a picture? What if the universe isn't truly solid and three-dimensional in the way we think? This is a mind-bending idea, one that some scientists and deep thinkers have been exploring. What if our entire universe is actually a giant hologram? So, what exactly is a hologram? You've probably seen one on a credit card, or maybe on a special sticker. It looks like a three-dimensional image, something that seems to pop out at you, even though it's actually printed on a flat two-dimensional surface. You can move your head, and the image changes, making it look incredibly real. But here's the thing. All that amazing 3D information, all that depth and shape, is actually stored on a flat surface. It's like a very clever trick of light and information. Now, imagine applying that same idea to everything around us. Imagine that our entire universe, all the stars, the galaxies, the planets, even you and me, isn't truly 3D in its most basic form. Instead, the universe might be like that credit card hologram. It looks 3D, it feels 3D, but maybe all the actual information that makes it up is stored on a very distant, flat, two-dimensional surface, like a cosmic screen at the edge of everything. What we experience as reality is just a projection from that distant boundary. It sounds wild, right? Like something from a science fiction movie. But this idea isn't brand new. For a long, long time, philosophers and wise people have wondered if the world we see is truly what it seems. Think about a video game. You're playing, and the characters move around in a 3D world, right? But the game itself, all the code and information, is stored on a flat disk or a computer chip. The 3D world is created from that flat information. It's a bit like that, but on a cosmic scale. This idea, sometimes called the holographic principle, comes from some very deep parts of physics. Scientists studying black holes, for example, found some strange things. They noticed that all the information about something that falls into a black hole seems to be stored on the black hole's two-dimensional surface, not inside its vast 3D space. This made them wonder, if a black hole does this, maybe the entire universe works in a similar way. Perhaps the true, basic information of our universe is like lines of code on a flat surface, and what we perceive as 3 dimensions is just how our minds translate that code. So, if our universe is a hologram, does it change anything about our lives? Not really, in a day-to-day sense. The sun still shines, gravity still works, and your friends are still real. But it does change how we think about what real means. It makes you wonder about the layers of reality, like peeling back an onion to find something even more fundamental. It's a calm thought to drift off to sleep with, isn't it? That the grand, sprawling universe, with all its mysteries and wonders, might just be a breathtakingly beautiful illusion, a magnificent cosmic projection. It doesn't make it less real. It just makes reality even more amazing. A puzzle that is far deeper and more beautiful than we ever imagined. It reminds us that there's always more to discover, more to wonder about, even in the very fabric of existence itself, and that's why it matters. It expands our minds to possibilities we might never have considered. The silence before a big storm. Have you ever noticed that strange, deep quiet that sometimes settles over everything just before a big event? It's like the world holds its breath. The air might get still, the usual sounds of birds or traffic seem to fade away. There's a stillness that feels different, a kind of heavy calm. It's not just an absence of noise, it's a presence of quiet, a feeling that something huge is gathering its strength, just out of sight. This isn't just about the weather, though that's where we often see it most clearly. Think about a summer afternoon. The sun might still be out, but the wind stops completely. Leaves hang limp on the trees. The air might feel thick and heavy. You might hear a distant rumble, but mostly it's just this intense, silent wait. And then, a few minutes or an hour later, the sky opens up and a thunderstorm breaks loose. That deep quiet was the storm's silent introduction, its way of telling you it was on its way. Here's the thing. This pattern of deep quiet before big change isn't just for storms. People have noticed this feeling for thousands of years, in all sorts of situations. It's like humans are wired to sense these shifts. Ancient people, living closer to nature, surely paid close attention to these signs. They knew that when the natural world went silent in a certain way, it often meant something big was about to happen. It was a warning, a moment to prepare. This quiet gives us a pause, a moment to notice, before the energy of the world shifts dramatically. Sometimes, it's just the physics of the world at work. Before a big thunderstorm, the atmospheric pressure changes. The wind often dies down, and this can create that eerie calm. It's the air itself getting ready, literally. But it's also a feeling that touches something deeper in us. It's a quiet that asks us to pay attention. Think about other parts of life where this quiet shows up. Imagine you're in a big room, maybe at a school assembly. Everyone is talking and moving, and then suddenly the principal walks onto the stage. Before they even say a word, a hush falls over the room. Everyone goes quiet. That silence isn't just a lack of talking, it's a shared moment of anticipation. Everyone knows something important is about to be said. Or consider the moments right before a big game, when everyone on the team is focused, maybe a little nervous, and the locker room goes completely silent before you run out onto the field. That's the silence before your own kind of storm. A moment where everything you've practiced is about to be tested. This quiet, this pause, can feel a bit strange, maybe even unsettling. It's like the world is holding its breath. But it also gives us a chance to hold ours, too. It's a moment to listen, not just with our ears, but with our whole being. It teaches us that sometimes the most powerful moments in life begin not with a bang, but with a whisper, or even with no sound at all. It's a reminder that even in stillness, great forces are at work, gathering their energy. And sometimes, the most profound wisdom comes from simply paying attention to the quiet moments, right before everything changes. The Earth's core. Still a mystery. Have you ever stopped to think about what's really beneath your feet? Not just the dirt and rocks, but hundreds, even thousands of miles down. We walk on the Earth every day, but beneath our thin outer skin, our planet holds deep, fiery secrets. And the very center of it, the Earth's core, is one of the greatest mysteries we still have. Imagine peeling an onion. The Earth is kind of like that, with different layers. The part we live on is the crust, super thin, like the skin of an apple. Below that is the mantle, a thick, gooey layer of hot rock, slowly moving over millions of years. But go even deeper, and you hit the core. This is the Earth's heart, its engine, and it's split into two parts, an outer core and an inner core. The outer core is made of liquid iron and nickel, flowing like a super-hot metallic river. And right in the very center, inside that liquid, is the inner core. It's a solid ball of iron and nickel, unbelievably hot, hotter than the surface of the sun. But because of the immense pressure from all the layers above it, it stays solid. So, why is this amazing place still a mystery? Think about trying to understand what's inside a tightly wrapped gift without ever being able to open it. We can't drill down to the Earth's core. It's just too far, too hot, and the pressure is too extreme. The deepest hole humans have ever drilled goes down only about 7.5 miles. That's like just scratching the paint on a giant car when the core is thousands of miles away. It's easier for us to send robots to Mars or even journey into space than it is to reach the center of our own planet. But here's how scientists have figured out what they know. They listen. When earthquakes happen, they send out waves, like ripples in a giant pond. These waves travel through the Earth. When they hit different materials, like liquid metal or solid rock, they change. They speed up, slow down, or bend. It's a bit like when a doctor uses an X-ray to see inside your body without cutting you open, or an ultrasound to see a baby. Scientists use these earthquake waves to create a picture of the Earth's inside. And that's how we learned about the different layers and what they're made of. Even with these clever ways of seeing inside, there's still so much we don't understand. For example, the liquid outer core is what creates Earth's magnetic field. This field is super important because it acts like an invisible shield, protecting us from harmful radiation from the sun. Without it, life on Earth as we know it probably wouldn't exist. But exactly how this dynamo effect works, or why the magnetic field sometimes gets weaker or even flips its poles, is still a big question. It's a complex, unpredictable engine. We also know the inner core spins slightly faster than the rest of the planet, but we aren't totally sure why or what it means. There are also strange, blob-like structures at the boundary between the core and mantle that seem to defy explanation. So, the Earth's core reminds us that even our own home planet holds vast, unknowable spaces. It teaches us a bit of humility. There are these huge, powerful forces shaping our world, right beneath our feet, and we can only guess at some of their deepest workings. It's a quiet reminder of how much wonder there is in the universe, even in the parts we think we know best. And that's a pretty amazing thought to fall asleep with. The strange story of Oumuamua. Imagine, for a moment, that you're sitting in your backyard, looking up at the vast, dark ocean of space. You know our solar system, with its familiar planets and moons, orbits our Sunday in a predictable dance. But what if one day, something truly unexpected just zipped through our neighborhood? Something that didn't come from our Sunday at all, but from a completely different star, light years away. This isn't a science fiction story. This actually happened in 2017, and the mysterious object was named Oumuamua. Its strange journey left scientists scratching their heads, sparking wonder about what else might be out there. Oumuamua was extraordinary. The first object we clearly identified from outside our own solar system. Think of it like a message in a bottle, not from a faraway ocean, but from another star system entirely. When powerful telescopes first spotted it, astronomers knew right away it was different. Most comets and asteroids we track follow predictable paths around our Sunday, or they were born here. But Oumuamua was just passing through, moving so incredibly fast it was clear it wasn't orbiting our Sunday. It was on a swift, one-way trip back into the deep darkness between stars. But Oumuamua wasn't just interesting because of its origin. It was strange in other ways too. For one, its estimated shape was very unusual. Scientists figured it was incredibly long and skinny, like a giant cigar or a flat pancake. Imagine a smooth, thin log rolling through space. Most asteroids and comets we observe are more lumpy or rounded. Even stranger, as Oumuamua flew past the sun, it didn't behave like a typical comet, which is usually made of ice and dust. When comets get close to the sun, the ice heats up, turns into gas, and creates a visible tail. We call this outgassing. But Oumuamua had no visible tail at all. It seemed like a bare, dark rock, or maybe metal, but it still moved oddly. Here's the part that truly puzzled everyone. Oumuamua seemed to speed up slightly as it moved away from the sun, as if something was gently giving it an extra push. For a comet, this speeding up could be explained by outgassing, like tiny rocket engines. But since Oumuamua had no tail and no visible signs of gas escaping, what was giving it that mysterious extra push? Scientists proposed all sorts of natural ideas. Maybe it was made of a strange, very dense kind of ice that didn't produce a visible tail. Or perhaps it was incredibly light and fluffy, like a giant cosmic dust bunny, being pushed by the faint pressure of sunlight. But here's the problem. None of these explanations perfectly fit all the observations. It was like trying to fit a unique, custom-shaped peg into a standard hole. Nothing quite worked. This led some serious scientists to wonder briefly if it could be something artificial, something made by others. They quickly looked for natural answers, because that's what science does. But the questions remained. The strange story of Oumuamua reminds us that the universe is vast and full of mysteries waiting to be uncovered. Sometimes, even with all our advanced telescopes and brilliant minds, we encounter things that simply don't fit neatly into our current understanding. Oumuamua came, saw, and left, sailing back into the darkness and leaving more questions than answers. It whispers to us of unknown worlds and processes, encouraging us to keep watching the sky, to remain endlessly curious, and to always be ready for the next inexplicable visitor that might drift in from the silent, star-strewn depths of space. It's a gentle, humbling reminder of how much we still have to learn, and that's a truly wonderful thought. Why do we get goosebumps? Have you ever noticed that strange feeling when your skin suddenly gets bumpy and your tiny hairs stand straight up? It happens often, maybe when you step out into a chilly morning, or when you hear a story that sends a shiver down your spine. Sometimes, it even happens when you listen to a really powerful piece of music, or when you feel a sudden wave of strong emotion. What is this peculiar reaction, And why does our body do it? This phenomenon, known as goosebumps, is a quiet echo from a very, very old past. It's your body speaking a language it learned millions of years ago. To understand it, think about what causes those little bumps. Each tiny hair on your body has a microscopic muscle attached to it, right under your skin. When these muscles get a signal, they contract or pull tight. When they pull tight, they make your hair stand up. And when all those hairs stand up, they pull on your skin just enough to create those small, raised bumps we call goosebumps. So, why would our bodies evolve to do something like this? Imagine our very distant ancestors, not just humans from a long time ago, but even earlier creatures, like mammals that had much more fur than we do. For them, having their fur stand on end was incredibly useful. When they got cold, making their fur stand up would trap a layer of air close to their skin. This trapped air worked like an insulating blanket, helping them stay warmer. Think of a bird fluffing its feathers on a cold day, or a cat raising its fur when it feels threatened. It's the same basic idea. That leads us to the second reason: fear or feeling threatened. When a furry animal felt in danger, it could make its fur stand on end to appear bigger and more intimidating to a predator. A tiny mouse, suddenly looking twice its size with all its fur puffed out, might make a predator think twice. It was a natural defense mechanism, a way to say, hey, I'm bigger and tougher than I look. Now, we humans don't have thick fur coats anymore. So, when we get goosebumps, that layer of trapped air isn't really going to keep us warm in a blizzard. And our standing up body hairs certainly aren't going to make us look like a giant monster to scare off a threat. So, why do we still have this reaction? It's because our bodies hold on to these ancient reflexes, even if they aren't as useful for us today as they once were. It's a bit like how we still have an appendix, even though scientists aren't entirely sure what it does for us anymore. It's a leftover, a whisper from a time when our lives were very different. Think about it like this. When you watch a scary movie and you feel a chill, and your arms prickle with goosebumps, that's your ancient brain still reacting as if a saber-toothed tiger is about to jump out from behind a bush. Or when a beautiful song gives you goosebumps, it's a sign of a strong emotional reaction, perhaps tapping into a very deep, primal part of your being that registers awe or wonder. It's our body's way of saying, this moment is important. This moment feels significant, even if I don't fully understand why. So, goosebumps are more than just a little chill or a funny sensation. They are a profound connection to our past, a subtle reminder of the millions of years of evolution that shaped us. They show us that our bodies are living museums, holding on to ancient wisdom and reactions that tell a story of survival and wonder. Every time you feel those little bumps rise on your skin, remember that you're experiencing a tiny piece of history, a quiet signal from the very first creatures who walked this earth. It's a gentle reminder that even the smallest parts of us hold grand and mysterious tales.